experience for reformers and fabricators. I'm Brad Kuvan. I'm the editorial director of metal forming at PMA, and happy to serve as your moderator today and tomorrow. This is actually our 5th edition of this event. We started it back in 2018. It was focused on IoT, and we decided this year to evolve it and encompass more of Industry 4.0. So we've got a presentation on additive manufacturing. We've got some presentations on automation, so what we consider to be kind of the 360 view of Industry 4.0. Plenty of IoT as well. And really the genesis of this event, some of you may remember, traces all the way back to 2012, 10 years ago, when Metal Forming Magazine launched our annual ERP software experience. So that was kind of the start of connectivity for us and focusing on ERP, and then it evolved into to what we have today. So it's been fun to evolve this conference along the way. So we're happy with you that you joined us this week. It's a smaller crowd. We've got another 10 people or so online. So we hope you will make this interactive. Ask your questions of these experts while you have them here as you're embarking on your Industry 4.0 journeys at your own companies. Want to thank Amada for welcoming us in this state-of-the-art facility. You're going to get a tour tomorrow. It's really quite something to see. So thank you to Amada. Also want to thank our sponsors. If you went upstairs, hopefully you had a chance to talk with Plex Systems, Principal Financial. Delmia Works is not upstairs, but they're a sponsor as well, so we thank them, and then Marpos as well. So thank you to for their support, which makes these types of events really something that we're able to do in a cost-effective way for everybody. Also want to recognize the other PMA and Metal Forming Magazine team members here this week. Perhaps you met some of them on the way in. PMA's President David Klotz is here, as well as Mike Voland, PMA's Vice President of Sales and Publisher of Metal Forming. Also here is Lou Kren, our Senior Editor, and Marlene O'Brien, our Editorial Manager at the registration desk. So please reach out to any of us over the next couple days if you need anything at all. And I also want to thank our event coordinator, Allie Miller. Some of you may have had some contact with Allie leading up to this. She had a huge role in getting us to this point. Last but not least, before we get started, I want to call your attention. You've probably been flipping through the folder that you have. A couple things to point out. One of the most recent issues of the magazine is in there, as well as a flyer that touts some other upcoming PMA events. So please take a look at those events and see if anything looks interesting. And I also want to let you know of a minor agenda change that we made. So the talk scheduled for this afternoon on condition monitoring. So we're moving that one to tomorrow, and we're going to move the additive manufacturing presentation up to this afternoon. Okay, so we'll go ahead and get started. Our first speaker this morning, really here to set the table and provide a kind of a 1,000-foot view of Industry 4.0 is Dave Plonin. Dave is the partner in strategy and operations management consulting with Plant Moran, and his opening keynote is titled Realizing Value Creation and Competitive Advantages with Industry 4.0. So Dave leads Plant Moran's manufacturing operations practice, focusing on manufacturing network and plant floor optimization initiatives. He has more than 30 years of experience streamlining and transforming business processes and operations, driving business change, maximizing profitability, and ensuring that technology investments deliver results. So over the course of his career, Dave's worked in a variety of industries, including metal processing, heavy industry, and automotive. So please welcome Dave Plonin.
Thank you. Okay, thank you very much. I appreciate you coming out. I'm really excited to kick off this conference, and so I appreciate you spending the time with us this morning. So it should be really great. Let's make sure that I can operate this perfect. So as Brad said, I'm Dave Plomin. I'm with Plant Moran. I lead the manufacturing operations consulting practice for us. 30 seconds on Plant Moran. We're almost 100 years old. We spent our first 50 years as an audit tax firm. About 50 years ago, we started adding consulting, wealth management, investment banking. So we're a full service provider for our clients. We've got offices in Michigan, Ohio, Illinois, Colorado, internationally in Mexico, India, China, Japan. So we serve our clients wherever they need it. So let's get to the good stuff. I'm really excited about the things that we're going to talk about this morning. I'm going to cover 5 things. The first thing is talk about a practical definition for Industry 4.0, just to set the stage, make sure that we're all speaking the same language. Then I'm going to talk about the 2 components of value creation that I think are really important. The first is establishing a roadmap, and then the next is benefits matter. After that, we'll talk about some peer examples, and then we'll close it with a call to action. Okay, let's get started then. So I think it's fair to say that there's a lot of confusion out in the marketplace about Industry 4.0 and what it is and why you should pay attention to it. It seems pretty clear if you look at the left-hand side and the timeline, it's the 4th Industrial Revolution. And the first 3 were all around 100 years apart. The first one started with the mechanized loom, and then the second one with the advent of the assembly line. The third one with the introduction of the first programmable controller. And then there was a faster pace where Industry 4.0 came out. So that makes it seem like, okay, Industry 4.0, I get it. But where it gets a little bit confusing is that where other terms come in. So, I've got a tag there under Industry 4.0 for the smart factory. But there's all these other terms that you see on the right-hand side. There's Industry 4.0, there's Manufacturing 4.0, there's Industry X, there's IoT, smart factory. There's all these things, and it kind of leads to some confusion about what it is and what do I need to do about it. And as a result, there's some companies that have stayed on the sideline and said, I'm not even going to worry about it. And so what do you do about that? And so what I propose that you do is you look at it more simply. And so my definition of the way that I think about Industry 4.0 is that it's a set of tools to solve business problems. And why this is different, or how this is different, is that businesses have been solving problems forever. How this is different is the set of tools are supercharged. They're like superhero tools because they're incredibly strong and they're incredibly powerful. And so I'm going to talk just a couple of minutes here on why they're different. The first one I'll talk about is that the connected nature of the solutions. And so with the Industry 4.0 tools is that you can connect what's going on the shop floor to other machines on the shop floor. You can connect them to your warehouse. You can connect to other departments. You can connect them to your management team so you can make better decisions. You can connect it to your suppliers, your customers, to the marketplace as a whole. And so that connected nature is really empowering for Industry 4.0 tools. The other one is the accelerated speed in many dimensions. And so it wasn't that long ago that I was a production manager at a specialty chemical plant. And I used to come in the morning and go right at the shop floor and try to figure out, well, what happened overnight on the overnight shift? What happened yesterday? Where were we? And so everything was backwards looking. And so I'd get an understanding of what happened yesterday, but I didn't have really the context of then what happened over the course of the last week or last month because everything was looking backwards in little small chunks. And now with the speed of information gathering that the Industry 4.0 tools provide, is that that's no longer the case. You no longer have to look backwards. You know real time what's going on on the plant floor. And because of that speed and that power of knowing what's going on now, the decisions that you're making now can affect, you can be thinking 2 or 3 weeks out in advance. And so now you're forward looking with these tools. And that's the big difference with Industry 4.0. And the last one I want to talk about is requires coordination and expertise on the bottom there. You're going to find that as a common theme over the next half hour as I kind of go through this presentation. I think that's what's different about Industry 4.0 is the way that when you're looking at the solutions, it's no longer just a manufacturing solution. It's no longer a supply chain solution. It affects everyone when you look at it. And so you need engineering, you need manufacturing, you need your accounting team, you need your supply chain team, everyone coming together and talking about these solutions. And so as just kind of a recap of this definition and why this is important, is that Industry 4.0 is a set of tools to solve your business problems. And it's a different set of tools than we've had before, which means the way that you address problems and you attack problems should be different as well. And that's what we'll talk about in these next few slides. So building a roadmap. So the first step to value creation with Industry 4.0 is building your roadmap. Now, your roadmap is just a plan over the next 3, 5, 7 years about what solutions you're going to be putting in place. what are the technologies that you need to put in place in order to solve the problems that you're having? What are the capabilities that you need that as the marketplace changes, as your customers change their needs, what are the capabilities that you need to put in place in order to remain competitive? And that should be mapped out in a roadmap plan. Now, I know that's not that earth-shattering, like everyone's like, well, yeah, you need a roadmap. But what I found with working with our clients is that a lot of times the roadmap is just in one person's head, or it's in a couple of people's head across the organization, but it's not unified, and so no one's quite aligned on it. And so the key with the roadmap is that it's got to be on paper, and you need to talk about it, get agreement and alignment on that roadmap to get the organization going the right way. And why should you do that? The first one is build a vision for the future. I'm a big proponent of building the vision and making sure the organization is all aligned on that vision. If you have a vision for where the organization is going, that's incredibly powerful for building a culture in your organization, to make sure there's alignment across different departments. Helps avoid urgent mistakes. And mistakes maybe is a mistake in itself. I maybe shouldn't have said mistakes, because what happens today is that there's problems on the shop floor. And what we do is we get tunnel vision. We say, I'm going to solve this problem right now. And then when the next problem goes, I'm going to solve this problem. And oftentimes it's not solved considering kind of a broader view of maybe where the roadmap is going. So we're working with a client today who has a problem with production scheduling, and so they are dead set on putting in a new application to help them with their production scheduling. And they think that's going to solve their urgent problem with production scheduling. On the other side of the organization, the IT manager and the accounting team is looking at a software selection for a new ERP system. And so if the manufacturing team goes forward with this one-off solution for production scheduling, how's that going to fit in with the ERP selection? And so that might be an urgent mistake, is we're going to buy something and it might be good for 6 months, but then when we bring in a new system, is that throwaway? I'm not sure. And it leads to the next one, which is the proliferation. So it may be, it's a great solution. And then we bring in an ERP system and we're going to run that ERP system. Now all of a sudden, instead of having one robust system, we've got a couple different systems that we got to maintain. We got to figure out how they talk to each other. And so having that roadmap helps prevent some of that. The last one I'll touch on here is that it doesn't have to be a 100-page detailed document. If it is, that you've gone the wrong way, because no one's going to look at it. And it's not going to do the important reasons why you build one, which is to be visionary, to get alignment along your organizations. So if there's projects on there in the next year or so, then you should have some detail around those. But if it's in the next 5, 7 years, you should have enough detail so that people understand which direction you're going, but no more than that, because otherwise you're spinning your wheels. So let's go a little bit deeper. How do you actually build that roadmap? What are the steps to it? The very first thing you do is you understand what your business problems are and you articulate them. And you talk about them as a team, as a management team across the organization, so that everyone's aligned on, here's the problems that we're going to solve. And being very clear about those problems and talking about them, and make sure that everyone's aligned on what you're solving and what isn't you're solving is important to building that roadmap. The second step is to map to a framework. And the reason I say map to a framework is that there's 2 reasons why a framework's important. One is, as we talked about a little while ago, these tools are incredibly powerful. They're like superhero tools. You want to make sure that you're applying the right tools out there to solve your problems. So you want to get rid of that tunnel vision of, here's a problem, here's my solution. A framework forces you to think about your solutions and making sure you're picking the right Industry 4.0 solution to solve whatever that problem is. So that's the first reason. The first reason is for a framework is it makes you think comprehensively. The second reason is a framework should have a maturity model associated with it. And we're going to talk more about the maturity model here in a second. The third step is to put it on paper, create a plan. If it's an immediate action, then the plan should be detailed with timing, resources, activities. If it's further out, 5, 7 years, how you're going to solve that problem, then it goes on the roadmap. So that's the process that you kind of go through. Let's dig in, again, a little bit even deeper than that. So this framework I'm showing here has got 6 components. It's an Industry 4.0 framework, people, equipment, analytics, material movement process. They're all interrelated, meaning that they affect each other. This is Plant Moran's Industry 4.0 framework, but there's a lot of frameworks out there. So it's not as important which one you choose, whether it's Plant Moran's, someone else's, doesn't matter. What you need to do is you need to choose a framework so that everyone in your organization is thinking the same way. And then the maturity model is applied to each of those components of the framework. So I think everyone's familiar with maturity models. It starts with, on the left, stage 1 is when you're kind of less mature in the journey. And then as you go up to stage 5, you're much more mature. And so for each of the components in the framework, there should be some definition about, hey, if my organization or if my process, my analytics look like this is where I am in the maturity model. A couple of the comments on the maturity model. Most of the firms that we work with are in stage 1 or stage 2. They might have a one-off solution that kind of is out there, but in general, they're on the left-hand side. And part of that is, the reason is that there has been that kind of resistance to Industry 4.0. People are kind of busy with their problems. They're not sure the benefits for pursuing this stuff. And some of these things in the technology is changing, so it's all kind of new. I haven't seen anyone in stage 5, and I would say that that's probably not the right stage for anyone in this room. And that's like way out there, and the value you're going to create by getting all the way to stage 5 at this point in time, probably isn't the right place. And so, somewhere in the middle is probably the right place for you. So I'm gonna pause there, and I want you to think about your organizations just for a second. And think about, and I know I haven't given a lot of detail about the framework, the maturity model, but I think it's intuitive enough. Just mentally think, in my organization, where would our organization line up on this maturity model? And so just think about it, and then hold that thought. Okay, so this is how the maturity model works and the components. So this is the same framework, but now instead of in a circle, it's lined up. And this is a case study for working with a customer that had problem with late orders. And so we helped them think through, all right, for each of the components of Industry 4.0, where do you stand currently? And so you see the boxes, the yellow boxes are the current. So we mapped out in the maturity model, here's how your processes map today. And then if we want to solve that problem, we want you to introduce some new technologies. Here's where your maturity should be in the future. And so you can see in some cases, it doesn't move. You stay in the same stage. So material moving to the bottom, whatever they had doing today was fine. There was going to be no value in moving that to a different level of maturity. But in other areas, there's things that should happen in order to create more value, to solve that problem. And I showed this because this is your roadmap. Each of these projects, activities, these new tools that we're showing going from where you currently are to your recommended ones, that goes in your roadmap. That's how you build your roadmap. And the difference between the recommended maturity and where you are today, that's the value that you're going to be creating for the organization. So now, on the previous slide, I asked you to think about where your organization might be on that maturity model. Now, if you just take 30 seconds and think about a problem that your organization is facing, and think about if you solve that problem, where would that move you on that maturity model? Would it move you up 1 stage, 2 stages, 3 stages, same stage? So as you think about that, feel good that you're already starting the roadmap process. You're already building a roadmap. So no matter what else you get out of this conference, know that you can go back and say, hey, you can go back to your boss. I started building our roadmap for the future. So you've got something done anyway. All right, so that's building the roadmap. Now let's switch gears and talk about benefits and why benefits matter. So most organizations, as they think about benefits and why they do it, is they tend to think of it as an exercise to figure out yes or no, do we do this project or not? It's the go, no-go decision. And for a lot of organizations, it's based on a pretty complex Excel sheet with macros and formulas, and it's in the accounting department, and they run their numbers, and they come up with, do we go or no go? And that's an important reason for benefits, absolutely. But it's not the only reason, as you see here, and it's probably not even the most important reason. So there's a couple of important reasons that I want to touch upon why you should go through a disciplined benefit process as you're thinking about an Industry 4 project, particularly when we think about value creation. The value creation, it starts with, well, what are the benefits that we want to achieve? So it forces that deep examination of proposed projects. As I look at organizations and work with organizations as they're trying to problem solve, everyone's really busy. Manufacturing's really busy trying to get orders out. Supply chains chasing down the disruptions with their suppliers. Everyone's just incredibly busy. And so having a benefit process that forces conversations about here's our problems and here we're going to do about it and here's the benefits we're going to achieve is incredibly powerful. It's incredibly powerful because it creates buy-in for the ultimate decision. Plant Moran, we're strong believers in that people support what they create. And so if you get people involved in defining what the benefits are, then they're going to buy into not only the solution, but they want to make sure that solution is successful, and you're going to achieve the benefits that you think you're going to at the beginning. I'm going to touch on just two more here. The second one from the bottom provides decision-making framework during the project. Every project that I've been on that is a big, complex project that has a lot of moving parts, we've had to make trade-off decisions during the course of the project. And I'm sure you've probably felt the same way. And so a lot of times those trade-off decisions are based on what's expedient in the moment or what's politically easy to make the decision. But if you've done a really good job with this benefit process here, those decision-making should be based on the benefits and preserving whatever benefits you thought you were going to achieve, and you got to make some trade-offs. It should be based on what is the benefits telling us we should be doing here. And then finally, it drives adoption work activities. The value creation part of it comes from deliberate activities that you do after go live, because the benefits don't achieve themselves. You have to make deliberate activities for achieving those benefits, and so having that solid benefit process drives the adoption work activities. So how do you do it? Well, here's the process. It starts up at the top with an idea, and then you define scope. The scope and the vision, I think, are the first two steps are the most important. Making sure you're crystal clear about what's in scope, what's out of scope, what are we going to do, and then not only being crystal clear about what's in scope, but getting agreement across the organization by affected parties so that everyone understands that we're doing this project and we're going to solve this. So there's no confusion about, oh, I thought we were going to do this. Oh, I thought we were going to get this out of it. So the scope and the vision does that for you. So you need to make sure that as you define the scope, you create the vision for where you're going, that you're communicating across the organization, that you're getting agreement upon it, that you're building momentum through it. The last one I'll touch on here is create the implementation plan. The implementation plan is really important because the costs are always incurred way before the benefits. And so if you are thinking that, hey, we're going to achieve these benefits right away, you got to make sure that you map that out so that there's not surprises halfway through and you figure out we're not going to get there anytime soon. As you go through, you kind of get to the end of determine the return on investment. And this is where it becomes an iterative process. So if the return on investment comes back and says, hey, this is going to cost us $15 million over 5 years, that's not a really great payback for us. We may not do it. You can decide, well, let's go through this loop again. Let's change the scope. Let's change our vision so that we can maybe get an ROI that makes sense. And so instead of 3 locations, let's do 1. Or instead of doing every machine on the shop floor, let's do the 2 sold-out machines and make sure that those are operating most effectively. So by looping that through, then you might get to the point where you need to be. So if you're doing benefits correctly and you're following this process, you're getting people involved, it's not an easy process. It's hard to get alignment on it. It's hard to do these calculations. So I'm going to offer up 2 thoughts on it that hopefully make it a little bit easier. The first one is the concept of intangible and intangible. So I think we all know that you want to get the tangible benefits. That's what drives the business case. That's what builds momentum. That makes sure that you're creating the value. What I would advise is to not ignore the intangible benefits, because the intangible benefits oftentimes are a great starting point for you. So oftentimes it's easier to say, hey, we're going to improve productivity, and maybe you don't know that exact amount, but that's a starting point. And so then as you learn more, you can start nailing down and get to the tangible, which you need to, but don't ignore the intangible. That's a great place to start. It's a great place to have those conversations. So work towards tangible, but starting with intangible is okay. The other concept that I think is really important is the concept of timing. So a lot of times for organizations, that benefit calculation, that Excel spreadsheet, it happens at the beginning of the project. You're deciding go or no go. And what's a more effective approach is to make sure that that benefit process is ongoing throughout the project. So once you get agreement like, hey, here's our benefits, we're going to go forward and go forward with that project, know that as you go through the different phases of your project, that you're going to know more information about benefits, and you should be updating that benefit plan. So you might find out that, hey, we thought we were going to increase productivity by 70%, and you might find out, well, the machine speed isn't going to match that. We're going to increase it by 50%. And so you're like, you've lost some benefits. But you also might find that there's other benefits that we didn't consider that now we need to add to the pile. And so you'll figure that out as you go through. And then finally at go live, you should have a very clear understanding and definition of what benefits you expect. And that's where the adoption activities come in, where you make sure that you need to be measuring the things that you thought you were going to save, where the benefits are. Otherwise, you won't realize that value. It's the stuff that happens after go live is really where you get that value creation. It's no longer an idea, but it's real. So how do you do that measurements at go live? You need to tie it to measurements that make sense for your organization. So the benefits should map to measurements that are part of the DNA of your organization. The financial statements, as much as possible, should be tied to your benefits. And the reason is because every organization lives by their financial statements, their income statement, their balance sheet. So as you think about your projects and where the benefits are going to be coming from, make sure you're mapping it to your financial statements. Now, I realize that not all benefits can be tied to your financial statements. Productivity is certainly one of them where unless your lines are completely sold out, then it's hard to point it exactly to a financial statement. In those cases, it should be tied to your KPIs that you're using on a daily, weekly, monthly basis. If you don't have the measurements in place for whatever benefits you've identified, then you need to put them in place really early in the project. You don't wait until go live. You start early and you start measuring that baseline of where you are and where you're going to be. This next one I'm just going to touch on just really quickly because there's a lot here. What this is trying to say is that for those Industry 4.0 frameworks, there's benefits that will be driven from that. So your framework should be able to identify, hey, if you do things in a certain area, you can achieve these benefits. I put this up there just to make sure that, if you're having challenges identifying what your benefits are, use your framework to help guide that through. All right, this is going to be a homework for you here. So when we talked about the roadmap, I asked you to have that mental picture of where your maturity was currently. And then I asked you to think about a problem that your organization is having, and then if you made some solution, like where would that move your maturity? And the difference between that future maturity and the current maturity, that's your value creation. That's where the benefits come from. And so think about your organization and any challenges you might have in defining what those benefits were. So, look at kind of the common challenges out there in defining benefits, and then look at the rules to live by and say, for the challenges that my organization would face, here's what I should be doing as an organization to counter those challenges. So think about that, and that'll help with your roadmap building and your benefit definition. There's only one other point that I'll make on this one and the rules to live by, and that's the develop benefit ranges based on uncertainty. A lot of times when you get into these projects, we mentioned quickly the intangibles versus intangibles versus tangibles, and it's a great way to start with intangibles, go all the way to tangibles. Another stepstone in there might be ranges. And so when you start a project and you're trying to figure out, hey, should we put in this new piece of automation? Should we add additive manufacturing to our capabilities? and you're going through that ROI benefit process, sometimes you can't nail down a certain number. What we can do is define what the ranges are. If it goes really well, this will be our number. If we are really conservative, here's the number. And how does that look for us? And then as the project progresses, you can narrow those ranges or nail into one specifically. My last comment on benefits is that recognize what your projects are that you're pursuing. So with the Industry 4.0 tools, some of those solutions can be transformative. They can transform your whole company. So for instance, with the Internet of Things, you can develop a complete, change your operating model to X as a service, like a software as a service, but it could be machine time as a service, whatever it is. So, with this information, you can really transform your company. And so it's transformational. Versus an incremental change may be that we're going to put a cobot in this area, and we're going to try it out. We're going to see what kind of happens. So that benefit process that we went through, you should tailor it based on the projects that you're pursuing. It should be way more robust for transformational changes than it is for incremental changes, just because the scale and scope is so different. So tailor your process for the given situation. All right, as we keep marching along here, I'm going to talk about some peer examples. I think it's always useful to put it into action, and it's what I'm excited about. The agenda for these 2 days is there's a lot of case studies, which I think is just a fantastic way to think about the Industry 4.0 and creating value for it. So the example I have here is the first one is a construction products manufacturer, and they had a very typical manufacturing line. The product started at one end, built the line, got to the end, and it's a finished product. And so what this organization used to do is they had pre-printed barcodes at the end, and they had an operator who would take the finished goods and they'd put it on a skid, they'd slap the barcode on there, scan it, and then eventually the warehouse driver would come around, take whatever skids are available, and then move them out to the warehouse. And so we think about, Industry 4.0 is a set of tools to solve business problems. And so the business problems here was that one is they had an inventory control problem because the labels were pre-printed, so labels were kind of everywhere. The operator would slap them on and scan it, and sometimes he would forget to scan or set it aside, or the warehouse driver would not come and pick up the skids and maybe send them over later and then forget to do that transfer out to the warehouse. And so they had an inventory control problem. The second business problem is that they had a staffing problem. This manufacturing location happened to be out in a remote area, hard to get workers. I think a lot of companies are still struggling with that, is finding workers. And so they had two business problems that they were trying to solve. And so the solution is that they tied the PLCs on their equipment in two ways. One, they tied it to their ERP system, so that when it got to the last stage of the line, it did a completion to the ERP, so the product was completed. And so we didn't need that scan at the end. But we still needed a barcode label because the material had to go to the warehouse. So we created put a printer on the line that was triggered by the PLC saying, print me a label, and then created an arm to slap that label onto the product. There's an automatic palletizer, and then eventually, as a second phase, developed a signal out to the warehouse to send an AGV, pick up my material, and send it out. And so as we look at our maturity model here, you can see kind of the power of mapping your different processes to what your current state is, and then where you're going in the future, and then if you have a phased project, where it's coming in. And so you can see that as we got to the first phase of the project, we made considerable slides. The second phase of the project will make even more. And so this would be represented in your roadmap, and it should be reflected in your benefit statements about where your benefits are coming from. Okay, the next example is a material processor, and the business problem that this one had was that they had productivity problems, and the productivity problems all came from their raw material supplies varied pretty significantly. Now, for the supplier, they were all within the supplier's spec. Like, I'm going to send you materials within these ranges. But for their processing equipment, that range was too high for them. And so what they used to do is they had a material inspector who would come in, he would test the material, he'd sort it into 3 different piles, and then talk to the operator, and the operator would then adjust the machine as they got, all right, here's this pile, I'm going to adjust my machine. Oh, next pile, I'm going to adjust my machine again. And as you can kind of envision, that led to pretty low productivity. It caused a lot of manual intervention there. And so the solution there was to introduce the Industry 4.0 tools of 3D cameras and automatic testing coming out of their raw materials. So it was no longer a sort process. It was fed through the line, and then the machine would adjust automatically based on the figures that were coming from the online scanning and the cameras. And so help that productivity. One more example here, and this is another metal fabricator. And what we did with this folks is that the problem that they were having is that they were slow to make decisions on the shop floor. So they didn't know if their materials were down, if their machines were down, were they making the right decisions about, do we stay down, do we keep fixing, do we go to a next product, do we go to the next machine? And so what we did here is we tied to the equipment to some management dashboards that showed on really simple screens about, are your machines running, how are they operating, real time. So the owner of this company could look no matter where he was in the world, here's what's going on in my Michigan plant. I can see that my machines are running, they're not running, that we're making the right decisions. And so it gives that immediate visibility and allows you to have faster decision making about if there's problems on the floor, what do we do about it so that I might have a bad day, but I don't want to have a bad month. The last pair example that I'll talk about here is in another industry. This is an injection molder. But they did some very similar things as the first example of as they had a material runner, and the material runner had to cover 12 different machines. And he would feed material to each of the injection molders. The molders would make their product, and then someone would come and they would scan the product, they put it in the warehouse. And then what they did was they tied the injection molders to the AGVs in the warehouse to come pick them up when they were in. And so they were doing those automatic completions. And what was different about this one is that the placement in the warehouse was also automated. So they know where there's spots open in the warehouse, and then that AGV would automatically put it in a location and do that warehouse transfer so that your ERP system always had updated information about where your inventory is. The next thing that they're going to work on, so it's a kind of a future one, is they're going to tie the injection molders to the storeroom so that there's better signals to the material runner about, hey, I need material in this machine in the next 15 minutes so that there'd be less downtime at the beginning as they were waiting for the material supplies there. All right, so that's the bulk of the materials that I wanted to share with you. I'll finish it with just a couple thoughts. And the first thought is there's obstacles to implementing Industry 4.0 solutions. Absolutely. I think you've got to recognize that happens. Hopefully some of the concepts that we've talked about in the last half hour will help. So where companies are struggling is, where do I start? Where's the right place to go? Building a roadmap helps that. Thinking about it as, what are my business problems I'm trying to solve, helps that. How to fund is a big question. If you do a robust benefit business case, it helps you understand about where your costs are, where your benefits are. Can we organize the projects so that they self-fund and that I'm getting enough benefits from these projects that I can fund future ones? Who can lead is a big problem. These are big, complex projects, and so you have to have a leader to do it. We didn't address that one. That would be a whole day talking about leading, but you got to address that one. How to continue, the roadmaps help you with that. If you've got a good roadmap, after you start completing work, you can go on to the next one. So my final recommendation to you is to think big, start small, scale fast. So the thinking big, that's the roadmap. Have a vision for where you want to go. Understand what's going on in the marketplace. Understand what your customers are demanding. Understand what new markets you might go into, and have a vision for that. and then start small. I think that things are changing so fast with technology, with the problems out in the world, is that you've got to think small in a way that you got to take action, and it's easier to take some small actions and then build that momentum rather than waiting for everything to be perfect. And then scale fast. I mean, once you start getting that momentum and you start getting some wins, you got to keep going. And then as a recap, I'll just kind of finish it maybe with this last one, and I was alluding to it, is you've got to start. We've talked a lot. I talked to a lot of clients out there, and they're waiting for perfect. And you'll be waiting a long time for perfect. And so you've got to be comfortable with being somewhat uncomfortable. Get the solution, get your vision, get it about 80% right, and then take some steps. And then know that you should react, though. Don't just press the on button and then expect it to be on automatic. You've got to start and then adjust as you go, as you learn more, and as more information comes from you. So that's what I have for you. So I appreciate your time and attention. Thanks very much, and have a great conference.
Thanks, Dave. Do we have any questions from the folks in the audience here? Go ahead.
This product goes away, thank you. If this product goes away, then we can use this automation for the next project that comes along, whether it's bowl feeders, camera technology, you name it.
Yep.
It's so expensive these days to automate.
Yep.
We want to be able to reuse it.
Yeah, no, that's a great point. I'm a big believer in having a flexible operation, just for the reasons that you mentioned, is that the market is changing so fast. The customer demands are changing so fast. Competitors are coming in that were never competitors before. And so you see it in like all industries where, the easy one that you always point to is like the brick and mortar department stores. Well, those have gone away with e-commerce, or they're going away. But it goes beyond that. You even think about in like the med device and the pharmaceutical industry. Well, those are all changing because of new competitors. The auto industry, there's all kinds of new electric vehicle competitors. There's Google that is competing in that area. And so to your point, is that the marketplace is really changing. Customer demands are really changing. Technology is changing very quickly. And so I do think that the old days of having one set process and think that's going to serve you for 10 years, 15 years, and you're just going to put out parts forever, I think it's changed dramatically. And so being flexible in your operations is incredibly important. Thank you for that. Any other questions?
Dave, I actually have a couple of questions for you. So that metal fabricator example that you gave, where they were concerned with one particular part of if it was one machine or just a general process issue on the plant floor, but so that's a situation where maybe you're putting out a fire versus a big, broad strategy plan, with a roadmap team and kind of doing the big wrap our arms around this strategy. Do you see a lot of that where they got to address one issue in the plant and then, so they fix that, do they go back and then do the roadmap, or are they still kind of doing that kind of the...
Well, yeah, no, yeah. Unfortunately, this particular company has like, it's kind of their nature is they're really good at problem solving as problems come up, and so they've got really good problem solvers. But what happens is they're chasing every problem, and then every problem has an immediate solution, and then they go on the next one, and that solution that they solve, they haven't thought of it at least broadly enough, and they don't solve it all the way to to completion. They're not done. They get it like 95% of the way done, and they go to the next problem. And so, the things that I'm trying to help them with is to make sure that you're done, so that when you give the solution, that you actually go through and you make sure that the users are trained, that you've changed your processes so that solution is part of your daily processes now, and it wasn't just a one-off because it was an immediate problem, is number one. And then number two is to think broadly about the solution. So a lot of the work that they're doing is they've got a 20-year-old ERP system, so they're bringing in these one-off systems, or we're helping them with some data analytics to develop some dashboards. And so, I'm encouraging them to think about, instead of what's going on in the paint department or in the stamping department, think about more broadly, how can we bring some of these technologies to solve a broader business problem?
Thank you. I do have one more if anybody else have questions before I ask?
Hi, Dave. I'm just wondering, you spoke to alignment at the beginning of the discussion, and I think that's a vital piece. But I'm wondering, from your perspective, or maybe from a percentages standpoint, when you engage with customers, what percent of them do you feel are aligned when you walk through the door?
Yeah, my immediate reaction is 0. But maybe it's 10%. Like for the broad range of clients that we work with, I think that's like the biggest problem. And I kept on hitting on kind of that alignment, is that, and it's not because people don't want to. It's just that, it's really like everyone is staffed thin. There's all these urgent problems, so everyone's really busy. You're trying to get stuff out, and so there's just not enough time in the day to align on what the problems are. Are you working on the right things? Are we, as an organization, doing the right things? And so you have to kind of prioritize that as a management team. And so having a big initiative like that, if you can force those conversations, it really helps, because it's hard to have those conversations naturally in the daily operations.
I'm going to ask one last question. Hopefully it won't take too much time to answer it. So all the way at the very beginning, you talked about this roadmap team, which sounds great, and we're going to get volunteers. Everybody's excited about Industry 4.0, but the reality, you said everybody's busy. And talk about your best practice advice for forming that team. How do you build momentum, and who's on the team? How big should the team be? Is it multidisciplinary? Is it top down? Do you try to build it from the bottom up?
Yeah, so I think it varies a little bit, but I think at the very beginning, and it was like the question that was just asked, is that it's the leadership team of the different departments. So you've got your head of engineering, manufacturing, customer service, supply chain. I mean, that's your leadership team that should be talking about this stuff first, and so I think that roadmap has to start with more of a vision, and it's got to start at the very top. Once you have a really good vision, then you can have individual projects that would go down to a cross-functional team. But I think the things that we were touching on, I think where I see organizations really need help, it's really at the leadership team level, where they've got to get that vision. They've got to start at least framing out a roadmap before you can assign it to another level of the organization to move it forward.
All right. Thank you, Dave.
Thank you.
So before we move on, I want to let everybody, just remind everybody that the presentations will be available after the conference. You'll get an email from us after we've download all that. All right. All right, so our next presentation, I think we're going to take a little bit deeper dive into some implementation strategy, which should build nicely on what Dave just talked about. Our speaker is Mark Marino. Mark is the Digital Factory Solutions Director at Polaris Automation. Mark has been helping manufacturers automate their businesses for more than 30 years. He's a leader in implementing state-of-the-art technologies, and at Polaris, he currently is guiding the efforts accelerating the digital transformation of factory floor operations focused on small to medium-sized manufacturing plants. So please welcome Mark Marino.
All right, thank you. I thought Dave did a great job. Thanks, Dave. And I'm going to talk a lot about the same kind of topics, maybe put a little spin on it, a little different spin, my interpretation. I agreed with almost everything you said. And I expect you to give me the same kind of compliment when I'm done. So I've been doing it, I think Dave said 30 years. I've been doing it for 32 years. When I started, the PC was just coming out. The personal computer was just coming out. I joined an industrial automation company that had been in business for 20 years. And they didn't have computers to go buy, so they built their own. They didn't have operating systems to use. They built their own. Didn't have software to use. Built their own. Burned them in proms at those days. Then they moved them to cassette tapes. So I learned a lot about inventing when you have to invent, but utilizing the technology that's available. And Dave mentioned that the Industry 4.0 tools are vast and great and supercharged, I think. And he's right. But still, you got to invent sometimes to achieve what you need to do. And it's really a balance of, what do we invent, what do we leverage with existing technology. And I'm going to talk a little bit about applying existing technology to really drive your manufacturing operations and improve things, the things you do and the way you do them. And that's what we've been doing at Polaris for the last 6 years. So let's talk again about what digital transformation is real quick. So in my mind, digital transformation is real simple. It's taking data and turning it into actionable information. So sometimes that data is pretty raw and in its bare form. We have to aggregate it across different sources to make sense of it, to put it in the right context. But once we do that and we can see what happened, why it happened, we can create actionable information. Then we want to do a decision based on that. And that decision and the effectiveness of that decision should be stored in a knowledge base so that we can recall it. And that's when we get more improvement, and that's where the artificial intelligence side comes in. So again, grab the data, collect it, analyze it, turn it into actionable information, make a decision, measure the results of that decision, store those results in a knowledge base. Then you're creating organizational intelligence. Not all data is created equal. So there's going to be a lot of data that's not useful in creating actual information. You really got to aggregate that, combine it, put it in the right context. So the concentric circles here are really the important part. And everybody wants to grab every data pieces and throw it in the cloud and have some auto magical system decide what to do. There's some hard work that still needs to be done in figuring out what that data is telling you. And that's kind of the pyramid on the other side of this slide. The process of turning data into actionable information. It's really collecting it, connecting to the sources of the data, collecting it, organizing it, analyzing it, summarizing it. Now it's information. What do we do about it once we make those decisions and actions? Make sure we understand the benefits. Did they work? We learn more when we fail than when we succeed. So, and that's just the way we learn as humans, and that's the way our organization should learn with these new tools and technologies. Let's talk a little bit about the process of that and the analysis process and those tools and the evolution of the analytic tools. So when we started, and these tools have been around for a long time, but when we started, and it's really I like this slide because the blue part is the automation of the data analysis, and the red part's the human interaction. So when we started with descriptive tools, and it really said what happened. So we might use a simple example. I might have a CPU that overheated, okay? So why did that CPU overheat? Well, maybe it was the temperature started going up in my control panel. Why did that temperature go up? Oh, my ventilation was stuck. It wasn't circulating appropriately. I had to go collect those manually to figure everything out and why it happened. So that's descriptive. So it's a lot of human interaction to figure that out. Diagnostic the tool combines that data for me. I can store it in a report, and it can pull that information together, and I can easier find out why it's happening. When we get to, those are the Ds, the diagnostics, those tools have been around for a long time. About 10 years ago, we moved into a different set of tools that did more, the Ps, I call them the predictive and prescriptive tools that did a little more analysis and predictions of what was happening. So now we can analyze the data as it's happening and say, oh, it looks like, our ventilation's going down. We better act, or else we're going to have a problem with our temperature and overheating. And eventually we can actually do some predictions based on, the temperature outside is going up. I wonder if that's going to cause my temperature inside to go up, which is going to cause a stress on my cooling, my ventilation system, things like that. So why do we care about digital transformation? I think Dave alluded to this too. We want to improve bottom line results. So this slide is 3 ups and 1 down. So we want to increase efficiency, increase our quality of the products, the things we build and how we build them, the speed at what we do, and reduce the cost. If we can do any of those, it's worth doing it, especially if it pays for the actual project. If it doesn't improve one of those, it's probably questionable whether we care or not on these particular data that we're analyzing and the information we're creating. So that's digital transformation, and that applies to any business. Collecting data, analyzing it, turning it into actionable information, making a decision, and then storing the results of those decisions. Now, when I think of Industry 4.0 and digital transformation, it's really how we apply digital transformation into the manufacturing space. We already talked about the 4 revolutions. I'm going to put a little spin on it. So the first revolution was all about, the mechanical aspects of using machines to make products. But the power was local power. We didn't have electricity. We didn't have a grid. When Industry 2.0 came along, we electrified the grid. Now power was now a utility, okay? And now we could leverage that. We could put our factories anywhere. We didn't have to locally source the power to energize those machines. In Industry 3.0, it was about computing instead of machines and electricity and powering machines. It was about controlling and automating machines with computers. And data, really the beginning of digitization was Industry 3.0. We also split into 2 groups at this time in manufacturing. We had our IT group, which was really focused on our ERP systems, our enterprise business solutions, and then we had the OT group, which was focused on how we apply computers to automate our control processes, okay? And that was all local computing resources, though. We put servers in closets, or we built server rooms, and then, we built control panels and put controllers in control panels. It's all local. And then we built, pretty strict interfaces between those 2 pieces. With Industry 4.0, now we have computing resources that are more of a utility. They're readily available with these supercharged tools, and we can leverage that. We don't have to locally source all these compute resources, and it becomes a lot more powerful. So that's my spin on the 4 industrial revolutions. This slide is real busy, but I don't want you to get caught up in all the terms, but I think it's worth having it so that you can review it later. But it's really a change in the way we build our systems for manufacturing. In Industry 3.0, we created a very structured hierarchical system, a pyramid, and we created very specific boundaries between layers. So at the top of the layer was the ERP level, and that's our business systems. Our IT group managed those, and we're very strict about compliance with with our business processes. At the bottom was our factory stuff, our machines was the bottom layer. The next layer up was the automation, really the Industry 3.0 controls, and then we put some software to monitor that above that in the SCADA layer. And then the level 3, the MES layer, was really a gap filler. It's not really structured. It's whatever you needed to fill the gaps between your ERP and business systems and what you're doing on the factory floor. With Industry 4.0, we want to share the information across these business systems, in Industry 3.0, in order to get to the top of the pyramid from the bottom of the pyramid, you had to make four hops through structured interfaces. You couldn't get real-time information shared between systems. With Industry 4.0, we want to break that. We want to cut that pyramid in half and flip it up and create a new common interface place called the information model, where anybody can get information from anywhere. So we'll have information providers that publish to this. It's called a canonical system. So there's a cone there, or a bus, that anybody can subscribe to information and get it on demand. Back in, the IT group tried to accomplish this about 15 years ago with service-oriented architectures and an enterprise bus. Now in our space, we're coming up with a universal namespace that's being that layer of information sharing. But it's pretty critical to build that out in our platform and our technology, because now we can share information, make better decisions faster across all layers. The other thing is our business systems don't have to be so segmented. We don't have to just say ERP. It could be a function of ERP. It could be financials. It could be business planning. It could be CRM. Break those up. You can use different systems, and they can talk to each other a lot more effective through this kind of canonical bus structure. Has anybody read The Goal? Hands? Good. It's a pretty good book. It's a long time ago, but I mentioned before the 3 ups and 1 down. Well, in The Goal, Eli Goldratt really, for manufacturing, boiled it down to bottom line results is 1 up and 2 downs. If we can increase throughput, decrease our inventory, decrease our operating costs, we're going to create bottom line results. So throughput is really shippable product. So, increasing throughput by creating stuff we stock is actually increasing inventory. So that's not the benefit. We really want to increase throughput to meet customer demand. And we want to balance the reduction of inventory and the operating costs. And at the time he wrote this book, he said the technology doesn't support it, so we have to do a lot of manual labor to do this. While with the Industry 4.0 tools, there's more technology available to support automating that thought process. It's still good thoughts, and it still applies, but I think the tools can be applied to help leverage it a lot better. And we'll look a little bit about that in a few slides. Like Dave mentioned, things are changing for us as manufacturers. We can't just build the same product over and over again. Our customers want different things. They want more options. So we're going from mass production, the same part over and over again, to mass customization. How can I leverage what I do and how I do it, but give my customer more options? The other thing is our labor shortage. I heard we got good news yesterday, but is it going to continue or not, that we can hire people and keep them in the position and really fill the labor needs to build our products. And then the supply chain. Before we had just-in-time inventory, we could rely on it coming in and spitting it out. Not anymore. So with all this stuff, I think Dave called it flexibility. I called it agility. We have to be much more agile and flexible in what we do and how we do it and react to today's conditions. Do I have parts to build this? If not, I need to move people and leverage their capabilities elsewhere. Or if I don't have the people, what am I going to do? So again, a roadmap slide. But this roadmap is really about taking that data and turning it into really actionable information for us to digest and measure true results of our bottom line. So, the Lean Six Sigma 6M method talks about manpower, machines, materials, method, Mother Nature, measurement. In my mind, I'm thinking in order to create this KPIs, this information, and improve our operations, we probably want to leverage each one of these components that makes sense, where we might have constraints and issues that are causing us to not perform as optimally as we could. So we're going to talk a little bit about how we can get data and turn it into information at least 4 of those levels. Manpower, machine, materials, and method. And the measurement side is really turning that data from those things into KPIs. Now, a little spin on KPIs. Instead of key performance indicators, I'm going to call it key performance information. All right, let's talk OEE. There's a big debate going on in the tech Industry 4.0 world right now about the value of OEE. The cons against it are saying it's just a silly metric. It's like taking your blood pressure, multiplying by your pulse and your cholesterol level, and coming up with your health indicator. But I take it like Dwight D. Eisenhower said, plans are useless, planning is indispensable. Well, OEE, the number itself might be useless. It's not really actionable information. But the art of collecting the data and turning it into an OEE number is indispensable. So let's talk a little bit about that. Availability. Availability is the measure of how your machine is available to run when you want it to run. So what's the data we collect to gather that? Well, the easiest, at the bare minimum, we need to know if the machine's running or not. So we can do that one of 2 ways. Give me a bit that says it's running and it's not running, or give me a cycle pulse, and I time between the pulses, and if it's longer than the takt time I want, we'll say it's down for that time until I see it running again. At the bare minimum, that's all we need for the OEE metric, but it's not very informational other than up and down time, so we can do better. If we have the data available, we can do better. So what we prefer to do is get the machine state, not just that it's running or not, but what is it doing? So if my machine loads parts, processes them, and unloads them, that's 3 steps I'd like to record. So I can trend how long is it taking to load, how long is it taking to process, how long is it taking to unload. It's all running, but it's nice to know it's better information if I know what it's doing. The other thing we like to know is when it goes down, why did it go down? If the machine can tell me why it went down, that's great information. I don't have to have somebody code it or after the fact say that this is the problem we had. The machine can tell me. So let's record that, create Paretos, and see if we have trends that we can actively go after and reduce those downtime events. What's best, especially in a complex process, is everything that's going on in that machine. If there's concurrent things happening, if it's a batch process and I'm mixing and loading and weighing, and you've got Gantt charts of phases. It's great to grab that information to really analyze what's going on in every step and everything that's going on in the process. And then instead of just grabbing the fault that caused the machine from going from a running state to a down state, let's grab all the warnings prior to that, maybe, and then we could get smarter about what's happening and why did that machine actually go down. And then what happened afterwards. We can see, a lot of times we can look at the alerts and see what the human person did to react to it. Maybe they didn't make the right decisions. So grabbing that whole history and analyzing it makes sense. It's important information. Performance. Performance is how fast I'm producing parts versus how fast my machine is rated to produce parts. So in order to calculate performance, I really just need that cycle complete pulse. That's all I really need to do it, and then we'll track it based on every time we see it. We'll increment our own internal counter and base it on a time cycle. It's better to know the actual machine telling us the product counts so that we don't miss potentially a cycle pulse, and what product it's building, especially if we're building multiple products, and we don't have to go post-fact and figure out what product we're building. It's really better if the machine tells us, because your machine rate's going to change potentially based on the product you're building. What's best, in my mind, is also to know what your scheduled rate is. If you're scheduling to your machine capacity and you care about on-time deliveries, it's probably a mistake. So what is your goals, and how are we operating to what you're scheduling? The hardest metric for OEE and to grab out of a machine is quality. A lot of machines don't have a quality indicator. Some do, but not all of them do. So we can, if there's an operator at the end that's looking at it and putting it in the good bin or the bad bin, we can give him a push button, say bad, or a foot pedal because he's busy with his hands or something. That works, and that's what we've done that in the past. It's better to have a defect counter if the machine, maybe we have a photo eye that says, oh, the part went this way or that way, and then we can count it automatically. We don't rely on a person to push a button. The best thing, if the machine can tell us, is not only that it was bad, but why it was bad. If it goes through a weigher and it's overweight or underweight, and we can trend that, that's the best way to get quality information and log that. So that's the OEE data that we like to collect, and we like to go as far down as we can in that pyramid when we're implementing an OEE solution to see how much data we can collect. Other machine data that's important to collect is our genealogy data to tracking. If you have serial numbers and a part goes through a process, we can track not just good or bad, but the actual process results for that particular serial number or batch or lot ID. That's getting more and more important in today's data-driven world. Maintenance. The first thing we want to know is when maintenance is performed and how you want to calculate predictive maintenance accumulators. So is that going to be hours run? Is it going to be cycles performed? Is it something else that the machine can tell us and we can track? And then when the maintenance occurs, we can reset those accumulators. And then predictive data. Maybe we want to know motor temperatures, amp draws, vibrations, so that we can predict that there's something, looks like it might be going out there and we should send a maintenance out to go deal with it. The last thing on the machines is just your normal time series historian data. We can use that to put more context on the information we're grabbing when we need it, whether that's temperature or process variables or whatever we're doing. And the set points associated, especially if we let our operators tinker with the settings, we'd like to record that and understand what they're doing. So that was the machine M. Let's talk about the manpower M, or personnel tracking. The thing we really like to do is record who's operating the machine. So we can do that with HMI entry or a badge ID, RFID read in. There's more and more geocodes and geozones available so that we can actually automatically track people as they move through the factory. There's even camera systems that do face detection and can actually analyze where you're at and what you're potentially doing if you're at an HMI or typing things in. That technology's coming and it's pretty good. The other thing we like to do on the personnel side is the training, track the training. So if we see somebody at a machine that they're not supposed to be at, we like to let people know that. Or if they're building a product, maybe they're trained for that machine, but this complex product comes into it and they haven't been trained on that. It's good to know that and make sure somebody comes over there and trains them. Then we want refreshers. This training doesn't last forever. How often should we refresh them? When did they give them the tools to say they refresh themselves, and we can reset our timer, but track that at this level. And then, give them the ability to do more and get more training. Maybe there's requirements for on-job training with another person who's qualified. Let's track that time that they're at that workstation with another trainer. So that's what we like to accomplish with manpower tracking. Let's talk a little bit about method tracking. Any of you guys use paper travelers with your work orders through the factory? We want to automate that. We really want to automate that. So the work order routings, if we can get that information and track where all your customers' order are on the factory floor, how long they've been in between processes, how long they're sitting. If they're waiting for something else, can we track that part and let the operator know, hey, that part is now coming in, let's push this up on the job stack. And we like to create job queues at each workstation and show you, this is all the work orders sitting at your workstation, and there's the priority of what I want you to do, and there's a contingency, you can't really process this because you're waiting for something else. And then we can do a lot of analysis about our methods and our workflow across processes. And I think that's when you think about the goal, that's really what he's talking about with theory of constraints, is making sure that you feed appropriately your bottlenecks, don't overfeed it, don't underfeed it. Focus on that. So that's really what we want to analyze, because these bottlenecks they move all the time. So it's not just a single bottleneck anymore. We've probably dealt with those. It could be based on time of day or certain flow throughout the day, or even break time or shift changes. I don't have the same people available. So there's a lot there on method tracking that I think we can improve upon and create a lot more valuable information. The last M is material and asset tracking, and really it's parts not associated with a work order that you need that you need to move into workstations. So that might be stocked items, trigger points. I think Dave mentioned. I call it e-Kanban, but the trigger to go restock parts, floor stock, or sub-assemblies that aren't associated with a particular work order, or tooling and die that we need. There's a changeover coming on this press. Let's make sure we get the die moving over so it's timed right. It's there. It's staged for that changeover, so we can be more effective when those things happen, because those changeovers are happening more and more with the agility needs. So where do we start when we want to create these key performance information indicators? It really depends on where your constraints are and what's most valuable to your business. So the first thing we do is we do a walk through the factory and look and talk with people and say, why is all this stuff sitting here? Or what's your biggest hiccup? Or there's a lot of scrap over here. What's going on with that? And really drill into and ask a lot of questions and get feedback. And then say, well, maybe if we could measure this, we could do a better job and understand the effects of what we see when we do our Gemba walks. And maybe it's changeover time. Like I mentioned before, maybe we can do a better job of staging the things we need for changeovers. Maybe it's personnel, and we can do a better job of staging people because we move them all the time across equipment. Maybe it's quality issues. It really depends on what we see, the feedback we get from the people that are stakeholders at the operations level. Once you create this information, this actionable information, you have to share it with the people that can use it and make a difference. So whether that's, I mentioned the job queues on the floor, the dashboards on the floor. As soon as you show people that you're measuring something, they're going to improve. That's the Hawthorne effect. They're going to improve just naturally because that's human nature. But that's just the first step. Once they understand the information, what drives it, they're actually going to give you feedback about, it'd be great if I had this information, I could do my job better. And you start getting more and more awareness of the power of the tools and the platform, the framework. And you'll get more and more of these KPIs going into the system, and your dashboards will grow, and your bottom line results will improve. So it's really important to share that information with people that are operational side, can make differences. Some roadblocks to avoid. The first one is avoid vendor lock-in. We talked in that one busy slide, I talked a lot about functional systems, function blocks instead of big monolithic systems. no software package can do everything great. So you want to use best of breed tools when it makes sense, and use all the new tools that are being developed and available. So don't lock yourself in thinking I just have to use vendor A's tools. Really evaluate what else is out there, and the technologies are evolving all the time. The next thing is the slide on the top right is what I call the IoT empire. You don't need to build an infrastructure empire, collect data from every piece of equipment everywhere on a plant floor, put it in a cloud, build a huge amount of analytics to figure out what my first KPI is. We use a lot of ROI calculations for CapEx projects. The private equity guys have a metric called time to value. Time to value is how long it's going to take for this investment to start proving that it's valuable. And that's a risk reduction variable that we should start using in our CapEx mentality. How long is it going to take to take the risk out of this project? So start small. I think Dave mentioned start small and scale big. The next one is corporate strategy. You probably have a digital transformation corporate strategy that you may or may not be aware of. But if it is there, leverage it. Don't ignore it. Say, I want to create some information from the factory floor and share it with the corporation. I think you're going to get huge buy-in. So look for that and really understand what your corporate digital transformation strategy is, if it exists. The last one and the biggest one is I mentioned in the Industry 3.0, the computing local resources between IT and OT. We have a real conflict between those groups, and it's not that it's not a personal thing, it's just a priority thing. So IT is mostly concerned about security and confidentiality and compliance and integrity. And the last thing on their roadmap is availability, where OT is all about availability. So I used to have a boss. I've worked for a lot of really titans in the industry, but one of the first CEOs I worked for was a real rough guy. But he went up to one of the VPs and said, "When are you going to get that done?" And the guy it was right when we had those Palm Pilots, and he started looking at his Palm Pilot, and he said, "No, you're looking at your calendar. I'm looking at my watch." And that's really the difference between OT and IT. OT is driven by the watch. IT is driven by the calendar. So what does success look like? Well, once you start building and sharing these KPIs, you're going to start seeing improvement. You're going to start getting that feedback about, boy, if you could do this, it would really help me. You're going to start seeing that growth model. You're also going to get a better feel for how you can justify CapEx projects with ROIs, because you got baselines. My KPIs and my drive bottom line results, and I have a baseline. So I want to take on a capital project, and I expect my throughput to increase. I expect my inventory to be reduced. I expect my unit cost to be reduced. And I have a baseline, and I can prove it once I implement it with that measurement. So it gets a lot easier to formulate these ROIs for CapEx projects. That's all I had. Questions? We got one right here, and then we'll get you.
Thanks, Mark. That was great.
Yeah.
Particularly interested in the manpower tracking, and if you can talk a little bit about kind of what you see as being successful in that area, and are you getting resistance from kind of the workforce or people on the floor about being tracked like that?
That's not the first time that question has come up. We're coming up with a new module in one of our platforms to do that, and it's it's an interesting question, but we're a professional services group. We put our time in time logs because that's how we bill. We're manufacturers. We need people to perform their work. We need to be able to measure how they're doing. And so it is a change management issue for sure, but I think it's something that we need to get used to. And put a scoreboard up there, more carrots than sticks probably, and reward the people that are your top performers versus punishing the people that aren't. Maybe that's a way to handle it, but there's definitely an issue there. Yes, sir.
Hi, Sean Brown. I was in the textile business, and we had one brand of machinery in the whole factory. Now I'm in the stamping business, and we seem to have as many brands of presses as we do presses. I met a fellow who built a fairly large machining outfit. He settled on one brand and ended up with 150 machines of that brand.
Mm-hmm.
You talked just at the tail end of your presentation about about looking at many different vendors for different solutions. And that actually is a pretty key question for us as we think about taking our plant into Industry 4.0, because you're worried about integration between the two. You don't want to have the wrong one. Is it a startup and they're not going to be here in 5 years? So I'd be curious to think from your perspective, how do you think about that decision for people like us?
Yeah, I think what we need to do with the machine providers is ask them, can you produce this information at these levels that I care about? And if not, why not? And if you can, that's what is most important. Now, I'm not sure there's a lot of variables you mentioned, and the Southwest model. I don't want my mechanics staff to know different planes. So maybe that's a variable. I don't really have a good solution for that, but I think there is a question of availability. Everybody's fighting supply chain, so a lot of OEMs you have to go who can get me something that I need in the time frame I need it. But then flexibility of the solution. A lot of these OEMs are really closed with the information in their systems, and they have to open up, because I can't have a separate OEE solution to share across my information model if I have individual silos. So in my mind, the most important thing is the information flow out of the equipment, but I'm sure there's more factors for operational that you have to consider. Yeah.
Anything else from Mark?
No.
One more back here.
Yeah, do you run across any issues with data contextualization or norming the data to be able to do something?
Sure, that's what we
useful?
do for a living. So
Okay. Yes.
Yeah. I mean, a lot of
Sorry, I
times,
walked
and
in
we'll
late.
put in an edge device to normalize data, or we'll throw it in the cloud through IoT, and then normalize it up in the cloud. A lot of times we have to spend, really understand the control logic and the sources of the data. What is it, so that we can best use it and formulate it. The other thing is, ETL tools coming down are vastly available. I mentioned service-oriented architecture. I was a big fan of the OAGIS standards for sharing data between business systems, but you can't get software vendors to comply. So you have to do your own ETL methods. It's work. Yep.
On the personnel tracking side again, Mark,
Yeah.
I really hadn't heard about that. Who's qualified to run what machines and barcode.
It's important with the labor shortage, isn't it?
Well, right. I would imagine it becomes more important as we have more turnover. And are we rushing people on the jobs just to get jobs done? And are we bringing safety into the equation? And
for sure.
You're protecting your own machines. Are you seeing more of that? Is that something that's really going on?
Yeah, we've had multiple instances from pretty large manufacturers come in and say, "This is a real problem. Can you help me solve it?"
Yeah. Okay.
Yeah.
Pay attention to that.
It is. It's a major concern for a lot of people.
Anything else for Mark? All right. Thank you.
All right.
very much.
Thank you.
All right. So we do have an hour programmed in for lunch. Lunch is back up in the room upstairs where the exhibitors are up there. So spend some time networking, have a good lunch, and we're back here in an hour with the first of our case study presentations. And again, I do want to especially thank the companies that agreed to present for us today and tomorrow on what they're doing in their own factories. It's not always easy to get companies to share that information. I'm sure you understand that. So I really appreciate Transmatic and the other folks that are going to be presenting. So that first case study with Transmatic's right after lunch. So we'll see you back here in about an hour. Thank you. All right, here we go. We're back from lunch. Thanks everybody for being so prompt and coming back when you heard the little chimes. Usually I don't get quite that 100% reaction. So thank you for coming back down. So, like I said before the break, I'm really happy and appreciative of the companies that are willing to share their stories with us in case studies. And so the first case study we've got of 3 or 4 is Transmatic. So Transmatic is a company, I think, and correct me if I'm wrong, guys, that's kind of more or less at the beginning of its Industry 4.0 journey. And so here to tell their story is Mike Kroll, Transmatic's Director of Global IT. Presenting along with Mike is Craig Scott. Craig's the founder of MFGX, which is a consulting company, I guess, right? Craig, that is helping guide Transmatic's journey on its Industry 4.0 path. So Mike's worked in IT for more than 30 years, beginning his career for electronic data systems and was there for 6 years before joining Transmatic in 1996. So in addition to his day-to-day IT functions, Mike has led the firm's Plex implementation here in the US as well as in China and Mexico, developed a global internet communications redundancy system, and most recently has begun to spearhead the company's Industry 4.0 and automation integration on the shop floor. Craig Scott is of MFGX, is in charge of SaaS application called Fuse, thank you, called Fuse. It's a SaaS application. So from his decades of experience running manufacturing companies and then implementing canned ERP solutions, he's formulated a one-of-a-kind solution that any organization can utilize. Prior to launching MFGX, Craig owned and operated a small fabrication, prototype, and tool and die shop. So I hope you enjoy hearing from Mike and Craig and their plans for taking Transmatic into its Industry 4.0 journey. And again, I want to thank them for sharing their story with us. So please welcome Mike and Craig.
You guys hear me okay? All right. Well, thanks for joining us today. Obviously, we'll share our case study and walk you through some of the things that we've done here at Transmatic. And as a gentleman introduced us, we are at the beginning stages, but I think we've done some neat things, and we're here to share those today. So. Our agenda, we'll go through some brief introductions. What's Industry 4.0? What does that mean to Transmatic? What some of the opportunities were that we were up against, some deliverables, our partnership with MFGX, and then what's next. Apologize if I go fast. I know we got a lot to talk about, and I want to make sure Craig gets his fair amount of time here as well. So we're going to go through this and, of course, ask questions at the end. A little bit about Transmatic. We're a deep-drawn metal stamping firm. We are a global operation. We're here located in Holland, Michigan, as well as Monterrey, Mexico, and Suzhou, China. We were established in 1968, and internationally, a little over 496 employees. And last year alone, we produced a little over 680 million parts. So, good production day for us is 2.2 million if we're hitting on all cylinders. A little bit about me. So my name is Mike Kroll. I'm the director of global IT for Transmatic. Went to Central Michigan University. Like the introduction was said, I worked at Electronic Data Systems. So back when Ross Perot, for those of you guys that are closer to my age, Ross Perot ran for president. He sold Electronic Data Systems, right? Sold General Motors. I was one of 90,000 employees at General Motors at the time. Worked at Buick Motor Division. Had a good experience there, but my wife and I wanted to raise the family on the west side of Michigan, which is where I grew up. So I transitioned over to Transmatic and have been there ever since. Craig?
Yes. So this is me. Love cars, things that go fast, and you got to make a big noise. So a little bit about me. I founded MFGX. We make the Fuse digital platform. That's what we'll be talking about here today, a little bit how we help Transmatic along that. Previously, started Cumulus Consulting for those of you in the Plex world. Ran that for a number of years. Before that, Metal Form Industries, short run, low volume fabrication company. So you can see I have a pretty extensive background in manufacturing, not just an IT guy, not just a software guy pretending, but I've done my own G code and M code, so I'm right down in the trenches with you guys. So looking forward to present here today what we've got to do. A little bit about the platform. So we are SaaS, cloud-based application. We do all sorts of things from production monitoring, process monitoring, MES, warehouse management, and really what you'll see here with Mike and his team is they've been able to take the platform and build out a lot of applications all on their own. He's got a great team that is just getting in there and building out solutions, and he's going to go through a number of those with you guys today, just to show you how empowering it can be to a manufacturing company.
Okay, thanks, Craig. So a little bit, what does it mean to us? I'm not going to read this. You guys can read this on your own, but the main thing is how are we going to do more with less, right? So I think everybody's in that same situation. How are you going to do more with less? Automation obviously is the driving force there. As one of our executive VPs had mentioned earlier, and we talk all the time, but Industry 4.0, it's a buzzword, I think. It's been out there, right? We didn't really understand what that meant, and a few years ago we started attending Industry 4.0 just like yourselves, and we're doing some things in that arena, right? But are we there yet? No. Do we think we're going to ever get there? Probably not. I think there's always room for improvement, right? So that's kind of how we address that. I think we saw this slide earlier. I call it the 9 pillars of what Industry 4.0 is. The things highlighted here in red, I think we touch on right now. Are we there 100%? Absolutely not. Big data, cloud computing. We have a CRM component in the cloud. We have our quote system is up in the cloud. Plex, our ERP system, is up in the cloud. For those of you guys that are using Microsoft Office, that's up in the cloud, right? So we have cloud computing. Cybersecurity is a component of this. We didn't spend any time on that, but it's the world we live in today, right? We have to have some type of cybersecurity. We implemented MFA. We have automatic updates being pushed out to PCs and so forth. So there's cybersecurity that comes into play here. Internet of Things, simulation. We talk about our engineering department, for instance. We use PAMSTAM in engineering to do simulations, right? We want to simulate what's going to happen in a metal forming product, a metal forming process before we actually go into the press. So learn what we can up front before we waste all our time, doing that in the press and then having to redo things. Then, of course, system to integration is a very key component of what we've done. So we interface with our CRM system. We interface with our quoting system. Our goal, and my goal as the director of IT, is I want to put data in one spot, and that's it. So if it needs to be visible or usable in other locations, well, then let's integrate. Let's figure out how we're going to get that data. And that's where MFGX comes in their Fuse product and helping us do that and make those API calls and make those interactions between those other applications. So some of the opportunities that we had, no different than I think a lot of you guys, and everybody else is faced with. We all went through the pandemic, right? So, but things really didn't change after, when we got into the pandemic, right? For us, it didn't change anyway. We still had to produce the same amount of parts. We still had the same requirements that, recording requirements and so forth. The data capturing requirements, all that stayed the same. We just had to do it with less bodies, right? Less people. We wanted to minimize some of our container movement, right? So we were moving containers and we wanted to try to minimize some of that. Highly skilled workforce. So at Transmatic, we have a highly skilled workforce. We don't have operators standing in front of a piece or a press watching it go up and down. They're off getting that next press up and operational, right? So how do we take that highly skilled workforce and utilize them but not have them do some of the every day-to-day tasks? How do we streamline that? More accurate real-time insights, better analysis of the data. So like every organization, I think we've done a super job of collecting data. Everybody does, right? That's what ERP system is all about, collecting all that data. What are you doing with the data, right? How are you using that? And I found that we really don't use the data as much as we collect. We don't use it to its fullest extent. So how are we making better decisions by collecting that data? So 3 things that we focused on. I know there was a lot of talk about a roadmap and things that, mapping all of this out. I'm just going to talk about 3 things that we focused on initially. We have more things in the hopper right now that we're focusing on and working towards, but I'll focus on these 3 for now. Automated recording of production. Wanted to streamline that process. Plex does a nice job. They give you a control panel and you can record production, but there was a lot of rekeying of data and trying to capture that. A lot of rekeying of scrap information, trying to capture that. So we wanted to see if we can automate that and streamline that as much as possible. Same thing with our quality lab data. All of our parts have to go to our quality lab. So we do some of our part checks at the quality bench. That's where our attribute checking is being done. But there's certain measurements that just simply can't be done with an attribute gauge, right? They can't be done with a visual. They have to be done on maybe a CMM, an OGP, a form trace, some other type of quality measurement device in our quality lab. So how do we do that and capture that data without rekeying all that information we just captured? So we'll talk about that. And then real-time visibility, information that's available on the shop floor to help us make more real-time, better real-time, quicker real-time decisions. So automating our production recording process. We built a new product with the help of Fuse and MFGX. We call it our PRS, production recording system. For you IT people here, if you don't have a three-letter acronym for something, right, you're doing something wrong, right? So PRS is what we called it. I see 3.0 up there, but we're actually at 3.22. So gentlemen earlier that spoke, we start, we roll out, you got to get moving, right? So we didn't build a perfect solution. We went through 1.0. We went through 2.0. We're at 3.22 right now. So we continue to fine tune as we go. But we put something in place to get started, right? That was the key. Get started, get moving, and then fine tune from there. And we find all kinds of things that people are asking for that, we continue to add. Adding diverters and reversing conveyors. So when we're moving product, we had to reduce our labor requirements. Our labor was restricted out on the floor, so we had less labor to move product, right? So how do we do that? So we added diverters and reversing conveyors, and I'll show you an example of what that looked like. And then we started producing into larger containers. We had an opportunity there where we saw that if we put more product into a larger container, we can still move it to our outside processing house in a larger container and not take up valuable resources of somebody physically having to move that container. We don't have the resources or the space to put conveyors in to automate some of that stuff, so we had to get smart about how we did that. So some of the benefits, we reduced transaction time by 88%. So, imagine having a 1 1/4 body full-time equivalent back, to do something else, right? So that was a huge benefit for us. We had one-click production recording and scrap recording. Operator could go by or toolmaker could go by and one click, and we're recording exactly how much production they produced and how much scrap was produced. And all those scrap counts and production counts are automated. We're capturing that automatically. We know the cycle on the press, right? We initially tried to do that through, we put ring sensors at the end of our conveyors and said, okay, let's count those parts. Well, that worked for about one day. And then we found out, okay, well, we got coolant falling onto that conveyor, and that coolant's dropping through it, and that's causing a misread. I just got a part. No, I didn't. I got a drop of coolant that went through. Or coolant was sticking, maybe causing parts to stick together coming off the end of the conveyor. Now I got 3 parts going through there, and they're being counted as one. So what's a more accurate way of doing that? Well, that's to take the machine data from a PLC or a smart pack. We run smart packs, pull that information right from the cycle count that's happening. So every time that press stroke, we know that that's a piece that's been produced. We've consumed raw material, we produced something, all right, so that's a count. So we were able to leverage that to capture production and scrap recording. Container quantities are controlled in Plex. So Plex has a nice spot to capture your overall container quantity, but we produce into, say, micro containers, say as small as like a little deli container, all right, because we're producing parts as small that go on maybe the size, the end of an ink pen, all right, so we have those parts that we produce. Well, they sit on a turntable, and that turntable turns every 500,000 pieces, and then those get dumped into a different container, and then they end up on a skid. So we were able to put some attributes into Plex and capture those quantities, through some attribute values in our ERP system. But what that produced and what that delivered for us was a repeatable and a sustainable process. Somebody mentioned earlier about process routings. Yeah, we did process routings, but a lot of the information was written on a process routing sheet. Well, that gets lost, right? You hand it over to the next shift to a different person, and sometimes they read it, sometimes they don't. So just to be able to create a repeatable and a sustainable process, we were able to put those numbers into Plex and generate that. Here's just a simple screenshot. We have about 65 active presses in our Holland, Michigan location, so I'm only showing you like 3 of them here. But real quickly here, if a manager were to look at this and bring this screen up, they can quickly see, what the status of that particular work center is. Now, I focused on just production on these 3, but we're running in production, what our job was, what part number we're running there. Real quickly, how many parts we've actually produced today, how many parts we should be producing, what's our schedule, and are we on, what's our job progress. All that's readily available and visible to supervisors and managers, as well as if we're running behind. The blue button down there provides us some additional functionality for some different features. Next screen, this is what we display on our shop floor. So we have a second monitor above our control panel for our ERP system. So we actually have 2 monitors at every work center on our shop floor. That's displayed on our quality bench. So our operators it's as simple, operators I call them, or our tool makers, can walk by and see exactly what's been produced and if they need to record production or not record production. So that production number that you see here, this is how many pieces we've produced since the last time we recorded. So that number will go to 0 once I record production, right? I've got micro quantities, tote quantities, and some other information there. Cavities, if we're producing into multiple containers, let's say we're running 1 out or 2 out or 3 out on a work center, we'll have multiple containers visible down there, and then some other information. So since I put this presentation together a couple of weeks ago, we've already changed this. So this screen's different already. That's what I talk about. We're at 3.2, well, we're at 3.22, right? So this has changed already. Just made it simpler. I was going to mention raw material. So we have raw material. That's where we load our raw material. I don't have to go into Plex to do that. I can do that right from here. We're pulling all that information in and allowing them to do that right in one screen rather than jumping around. Down at the bottom is where I record production or I record scrap, where I can do both. This is a screensaver that we developed. So after 3 minutes of not doing anything on that particular screen, I'll throw this screensaver up. It gives quick visibility when somebody's walking by that particular work center, what the status is. Green is good. We're in a production status. We're running. If this was red or pink, as it kind of looks like in Plex, means we're down for some reason, right? Also tells us how many parts we produce and how many containers we have ready to be recorded. So as an operator, if I see all zeros there, I can just keep walking. I don't need to stop and record anything. I know that there's nothing to be done there, right? I mentioned reversing conveyors and larger containers. Well, here's an example of larger containers. We run into mini mags. Before we were running into a container, see the red container there in the middle? We had blue containers sitting there on a conveyor that we would manually move, and those would get filled up. Well, we were filling those up every 10 minutes, I think. So we're producing that quickly, filling that up in 10 minutes, and I'd have to have an operator move that over, and then we could fill up another one. So now we can run, I think in this particular part, we're running 10,000 parts into that mini mag. We have a diverter set up. That information's being fed from our Plex quantities. We're feeding that back into Kepware, which is being read by our Smart Pack. Our Smart Pack then is taking and making a switch and telling it, hey, you've just produced the maximum amount of parts that you need for that container. Flip that diverter, and now I'm running product into the other container. So I've minimized my container movement and my interaction with tool makers because we have diverters running. If we run into a down situation, press is top stop, somebody shuts the press down. There's a flipper on there. Not going to go into the technical details, but that flips over, that motor flips over, and all those parts get run into our scrap bin. Again, I'm counting all of those pieces that have been recorded there and will run into our scrap. So now I've got accurate scrap and accurate production to be recorded. Another huge benefit for us was in our quality lab. Parts will go to our quality lab, and they have to be measured, whether it's every 2 hours, every 4 hours, every 8 hours, right? And there's check sheets for those of you guys that run Plex as your ERP system. There's check sheets that you create in there, and you capture that quality data. So what we were doing before is we would run quality checks. Our lab would do the measurement, whether it's on an OGP, and that we would take care of 3 measurements. And then the CMM, we do another measurement, and that would handle, 4 of the different measurements, right? And all that information would have to be punched back into a check sheet. Now that's all automated. We've got program running in the background that looks for data that's being collected on the CMM, that's being collected on our OGP, that's being collected on any other measurement device in there, and automatically taking that data, feeding it back up into Plex, and putting it into the appropriate check sheet. It knows the part we're running, it knows the job we're running, and it knows what particular check sheet it has to be put back into, whether it's a 2-hour check, a 4-hour check. So all that has been automated. So we've eliminated having to manually key punch that data back into Plex and into our ERP. So again, the benefits, eliminating manual rekey punching. We estimate we're about a one-time full-time equivalent there, one person there. It's a huge savings, especially in our quality lab, trying to staff 3 shifts, and that's difficult to do. So we're able to eliminate that. We've got better visibility in our shop floor. If one of those measurements was out of spec or out of control, that information is put onto a display screen and visible on the shop floor. So the tool maker that's in charge of that particular work center has immediate notification that, oh, something's wrong, I'm out of spec, I'm out of control, I need to top stop that press. Now, is there more we could do there? Absolutely. Could we force a top stop from our system because we know it's out of control? Absolutely. But we can't convince our tool makers yet to do that. So they don't want somebody just doing that and trying to figure out why we top stopped it. So it's a work in progress. Moving on. So here you can see, here's just a quick screenshot. This is information that's displayed on our shop floor, but you can see in that far column there, our lab results. So on our 300B press, we're running our T1340 part. I got 11.1, it's out of spec. My measurement 11.2 is out of control, and my measurement for 19 is out of spec. So they have immediate feedback in what particular measurement was at fault or went bad, and they can address that. I'll share a little bit here about our, in a moment. You don't get too far ahead of myself here. So real-time visibility of shop floor performance. That was the last thing we focused on. So we have display screens that we use throughout the shop floor to give our tool makers visibility, our tool managers visibility of everything that's going on in the production area, as well as other areas. Maintenance has visibility. Operations, our logistics department, our receiving department, they all have a screen that displays information in real time for them, and that's all coming from our ERP system, all through integration. And again, all that's developed because of Fuse and MFGX and some of the things we're doing there. So benefits, immediate visibility on press statuses. And of course, obviously that helps with containment. If we run into a quality issue, we can stop that situation, contain it. We have better containment there. So this is a little bit fuzzy, but gives you an idea of what's going on with a particular business unit. So we separate our presses into different business units. And in this case, our statuses, let me just talk a little bit about our statuses and how we organize those. So, a status you would think, oh, it's either running or not running, or active or inactive, right? But we added a little bit more intelligence into the status definitions. We could have a work center that maybe we have got planned downtime for, or we could have a work center that, hey, we're running production, that's great. Or we ran up against a quality concern, and that's a concern, but not a concern where we're saying, hey, we need to stop the press. We're going to go ahead and allow that to run because maybe we've already fixed it, but we moved it, but it has to be remeasured, in our quality lab, so they need to use that equipment. But we're confident as a tool maker, they're confident they have the issue addressed and fixed. So we're willing to take that risk to keep running because we produce so many parts in a day that we're going to run under production concern, but we'll get out of that status in a short period of time until that measurement comes back and shows that it's good. We have a maintenance status. The way we look at our statuses is who has the ball, who has control, who do we need help from. So if we're running, that's great. That's in our production status. But if I need help from, say, maintenance, I'm going down because I have a maintenance concern. Well, we put a maintenance status in there. So I need maintenance has the ball. They need to help us. we need help from that department. If I'm down because, for operations, let's say it's a cutting issue, I got a tool issue, they're doing something. I know that it's down for operations, so my operations or my tool maker are working on it. If it's down for forming, because there's an issue with the die, they're working on that. So those are different statuses and intelligence that we've built into our press statuses that also help us identify what's going on and who has the ball and who we need help from. I could put a press into a engineering status if I needed help, because engineering has to update a print or do something there. So that's just a little bit about statuses. A little bit more about our partnership. So with MFGX and Fuse, we have over 100 workflows that we've built so far through the Fuse product. So we talk about digital transformation. We couldn't have done that without the Fuse product. On our production floor, we got real-time status screens, by business unit. In our receiving area, we will receive tools in, and it's very difficult for our receiving coordinator to pull that information and identify, okay, where did that tool come from? Some of our tools are built, at different locations, mom and pop shops, that kind of stuff, and well, they don't always label everything very well, right? So we know things are coming back in, but we need to put a label on there, so we need to know who ordered it, where has it got to be delivered to, and does it meet our requirements? So we've done that, and that was done through through Fuse and MFGX and putting a label on those components. So knocked out what was normally a 3-hour job to 20 minutes. So logistics, if we're needing to notify our logistics department, what's going on in logistics? I need material. What do you need? Or do you need packaging material? Or do you need to come pick up material? It's a simple status change right at the work center, and they can make that status change, and that automatically gets displayed on our logistics screen that's there for them only, and they know what to do. They know what raw material to deliver. If it's a raw material need, it tells them exactly what to bring. Maintenance, the same thing. The lab, we already talked about that. If we go into an out-of-control status or out-of-spec. New tooling orders. So we use MFGX and the Fuse product. If you can imagine building a tool for a stamping press, if you've got 17, 20 different stations and you got multiple stations, so multiple detail tools for each one of those stations, there's hundreds of pieces of tool that go into tooling, right? So from our engineering system, we download all that new tooling information, put that into a spreadsheet. We're able to upload that through the use of MFGX and the Fuse product into our ERP system and generate the necessary requisitions. And we also can identify, hey, we're going to build these tools in-house, or we're going to send these to purchasing to farm out to the outside world. So all that's done in an automated fashion. We do CRM, Plex integration. Again, I talked about two-way integration. So new customers, new orders, new parts, anything that comes in, we will integrate that into Plex right from our CRM. And then vice versa. If we have somebody else changing data in Plex, let's say a customer name wasn't typed in right, or it had to be changed, or contact information was changed, we can put that into Plex and we'll feed that back into our CRM system. So we've got two-way integration happening there. And I've talked about PRS and integrating with Kepler. So Craig, that's all I had. I'll turn it over to Craig, and then we'll open it up for Q&A.
Yeah, thanks, Mike. So I think, as you guys can see by Mike's presentation, there's a lot more to a digital transformation than just simply monitoring a piece of equipment on your shop floor. They've got e-commerce integrations, a bunch of workflows, really automating business processes, back-end, reduction in overhead. That's really what we're all trying to do here. So we've partnered up with Mike. We consider ourselves, a technology partner. So we want to enable Mike and his team to be able to do these things on his own, right? You don't want to go back to the vendor constantly. And earlier today, somebody mentioned that vendor lock, right? Every manufacturer offers their own software. So everybody can collect OEE. You end up with 10 disparate pieces of software. Good luck getting them all to communicate. So I think a lot of these kind of resonate. This is why Mike and his team decided to move along with a product like ours. And these concepts all lead down here to cost reductions, better, more accurate information, one source of truth. I think Mike mentioned that too. And greater levels of adoption. right? When you have fewer things that your employee or workforce has to learn and understand, of course, they're going to gravitate towards that much better than they would elsewise. So that's really just wanted to put a bow on the top there and kind of, explain to you guys what we do, how we do it, how we've been able to partner with Mike and other companies, and now move on to what is next.
Yeah, what's next? So I mentioned we're at 3.0, we're at 3.22 right now. One of the last things we just rolled out, it was maybe a week or so ago, I'll share an example, made a modification to the display screens. And we actually know what our actual run rate is and what our quoted standard rate should be on that particular work center. So we added that column to one of the display screens and put it out there, and then we put added some color coding to it. And sure enough, one of our second shift operators came in and noticed that we had rolled out some new code and some new information. And he looks up and he says, well, I'm working on that press. Why is that yellow? He couldn't figure out. He's like, Then he put 2 and 2 together, and we hadn't told him yet. We were going to tell him, but we hadn't told him yet. Before we had an opportunity to say anything to him, he cranked the speed up on that press and said, oh, yeah, I'm not supposed to be running at 44 or 50 strokes a minute. I should be running at 52. And he cranked it up, color code went away, and he knew that he was running at the proper speed. So just something that simple, that visual, bringing that information in, it's there. We have the data, right? But making it visible and usable, big difference. So some of the things we're looking at moving forward, tool hit tracking and ordering. I know there's modules in Plex that allow us to do this. We're looking at leveraging that, and we've got a lot of work being done right now behind the scenes, planning that all out. It's a little more complicated than what it sounds, but we want to make that a straightforward, simple process, especially the reordering of tools if we need to. But this leads to more predictive analytics, right? Because we know after X amount of hits on a particular tool that it has to be pulled and has to be sharpened or it has to be replaced or something should be done with that because we start to see a trend on our quality data. So let's get ahead of that. Let's predict when that's going to happen, and then let's send out an alarm or a notification to a tool maker to say, hey guys, you got to pull that tool, okay? Let's not wait for that light bulb to burn out. Let's replace it before it burns out kind of thing, right? So we do that. Augmented and virtual reality, I think, is another one. That's one of the other tools that we talked about. I think we've got a huge opportunity in terms of training. We bring in temporary personnel to do, assembly work or, some other work. I think there's a tremendous opportunity for us to leverage that, one consistent source of here's how you do this, right? You get into situations where, and our age for our company is getting, older and older as well. So, so we're starting to get into, and you start using some of the trainers, and all of a sudden that training gets watered down, and they forget to say, oh well, yeah, after you fill that box, you're supposed to move it over here. Well, if you leave that little important piece out, it doesn't happen, right? So if we can offer an opportunity to consistently train and have somebody just focus on that and not have to worry about training, we eliminate the need for a trainer, number one, to have to go through and do that. Because we have a different means of doing that. So those are, a couple of things we're looking at. We've done some things with, we're working right now with forecasting. It's not on here, but we've developed a forecasting tool that's pulling information, from our existing ERP system, a couple buttons, and we put the rules together. You hit a couple buttons, and we can put a forecast out there for the next 3 years. We know exactly what we should be, what our budget should be or what we should be budgeting towards because we're able to pull that information in rather than right now I think we spend 4 hours, 5 hours in a day and we bring in the head of sales and the head of finance and the head of production control and they all sit in and hash out what should be ordered. And that information's there, so we just need to use it. So that's all I had. Questions?
Mike, what was the timeline for when you decided to kind of go down this path to where you've gotten to today?
So we've used a number of tools. Fuse is a big component of that, but we use Ignition and our ERP system and all that integration and the whole timeline. Really, I don't want to say it really started with COVID, you know, I know that was kind of the impetus that pushed us over the edge, but it was even prior to that. We knew we had the capability to do integration. We captured that information, you know, from Kepware. We talked with other individuals that had products out there that, you know, leveraged data that was captured through SmartPacks and Kepware, and we knew the information was there, so we started looking at that. But yeah, I'd say we probably put a real strong push onto it in, you know, the last 3 years, 4 years. Yeah,
Come a long way, and
we have in a short period of time. Yeah.
You integrating some of that technology with your vendors for consumables?
Not yet, not yet. But absolutely, I mean, the data's there, right? We know when we're going to run out of product. I know we've done some things on our shop floor, like in our assembly area. Not only do we assemble, you know, parts from our own that we produce, but we have to bring in purchase parts and purchase components. And we know when we're running low on that inventory because we're consuming it at that particular work center, that we're driving that information back to our logistics department to say, hey, you need to bring another box of this, or they need more parts here because we're running low. But we haven't pushed that out to our vendor yet, not yet.
Thank you.
Yeah.
How does ignition fit into that picture?
So
Can't tell you anymore.
you can't tell me anymore, all right. So ignition is, how do I describe ignition? Ignition is a bunch of tags on steroids. It's just, it just captures, you're able to do so much with that and automate it.
Most
Infuse.
of the machine-to-machine communication that you guys are doing on-prem,
Yeah.
it's primarily what they're using it for between Kepware and the SmartPack controllers to set up the diverters and just basic logic.
Yep. Correct.
Yep.
Yes. Yeah. Then there's PHP code, and then there's, you know, HTML code to make those screens. There's just a lot of different pieces there that make this all work. So, and it requires a very smart resource, and that's not me. So.
Just a quick question on the, you mentioned like moving tools and replenishing inventory or the taking the inventory away, et cetera. Are you using AMRs at all, or are you going to look into using robots for automated logistics, or is that something that's like future?
So we're looking at, our engineering department is looking at that. You know, we're kind of restricted based on real estate on our floor because we have so many work centers, you know, I want to say compacted or jammed into a small, you know, footprint, so to speak. So we're kind of limited on what we can do in terms of automation. We do have some robotics, and we are moving parts that come off a particular press, and we are using those in certain instances where we're using those robotic arms to put parts into boxes and put parts into containers. So I'm not saying we don't do that. We do that today. Is there more room to do that in the future? Absolutely. Yeah, I think the sky's the limit. So it's just a matter of how much you want to invest in that. You know, at what point, how far do you take that? You know, we automatically generate labels, right? But it still requires manual intervention to take that label off the printer and slap it onto a box, whether it's a tote label or a whip label or a finished good label. You know, so there's room for automation. I know somebody shared an example this morning about how they do that, you know, automate that. I think there's room for us to look at doing that. We're looking at, you know, how do we automatically load coils into a work center? You know, is that a possibility? And we're looking at different things there to maybe streamline that process. Yes.
So like I said earlier this morning, we're going to move things around a little bit. So the condition monitoring presentation will be tomorrow. We're going to change directions a little and talk about additive manufacturing, which is a big part of Industry 4.0. I know some of you attending today probably already use additive manufacturing in one shape or another, maybe for rapid prototyping or fixtures and end-of-arm tooling, that type of thing. But a lot of manufacturers are starting to go beyond those applications. I think we're going to hear about them and maybe some other applications with this next presentation, which is going to reference some case studies and explain how metal formers and fabricators are using additive manufacturing to evolve from idea to end part. So our speakers are from Markforged. First, Ross Adams is a product manager with Markforged, responsible for its metal product roadmap. He's got a mechanical engineering degree from UMass Amherst that prepared him for initially working as a tool designer in the aerospace industry. He then transitioned to application engineering at Markforged. And then joining Ross is marketing manager Daniel Leong. Daniel spent the past 6 years at Markforged. He's a mechanical engineering graduate as well from Olin College and has experience in mechanical design and simulation, as well as product design, program management, and marketing. So please welcome Ross and Daniel from Markforged.
I didn't write that bio. Let's try it. Just a quick show of hands so I know what we're working with. How many of y'all work with 3D printing today? Okay, half. That's about what we expected.
Yeah.
You got a clicker, right?
I can click.
Cool. So we're at Markforged. That's me with longer hair. It's on. Is it too far away? I'll move it out.
Give it like a little tap.
Oh shoot, I think it buttoned off. Wait.
Yeah, press it.
Got it. I think it, there we go.
Technology.
Yeah. Technology. That's what we're here for. So we're both with Markforged. We both have mechanical engineering backgrounds, and both don't work as mechanical engineers anymore, but use our printers all the time. So I think what I do primarily at Markforged is work with companies like y'all and figure out how additive manufacturing actually fits in your journey. And how to bring it forward. We've talked about a lot of different things today, and I've seen additive manufacturing referenced about 6 times on slides, but no one's actually talked about implementing it. Compared to other Industry 4.0 things, it's kind of an odd duck, because when you're thinking about a lot of conventional Industry 4.0 tenets, you're talking about instrumenting or sensoring equipment you already have, whereas additive manufacturing is much more disruptive. It usually means bringing something new in that you don't necessarily know how to use, that you don't necessarily know the rules for, and you don't actually know how to get success naturally. So that's what I do, and Ross works more on the actual printers themselves.
Yeah, so as a product manager, I kind of obsess over the customer experience and what they use the printers for today, where they're really successful with it, but then forward-looking, where the opportunities lie. And then I try to take that feedback and align it into a product roadmap. 1 year down the line, 5 years down the line, 10 years down the line, what does 3D printing look like for these future applications that customers can use and solve on the manufacturing floor? So I work very closely with the engineering department, but also with our marketing team to ensure that we're getting these messages out there. People are realizing the value of our technology.
So a little bit what we're going to talk about today, we offer both plastic and metal printing solutions. Given the audience, we're going to talk mostly about metal today. So we'll give an intro to what our process is, which we call Metal FFF. There's a bunch of different names. It turns out every 3D printing company thinks their process is unique and comes up with a process name for it. And so there's kind of a whole wide variety of those out there. So we're going to keep it simple. We'll talk about strengths and weaknesses of our process. 3D printing is good at quite a few things and bad at a lot of things. So we're going to focus on what we're good at and then also talk about what parts tend to be successful. And then we're going to talk about 2 separate case studies, go into companies that went into looking to automate parts or change how they make parts or kind of reinvent their supply chain in difficult times, and how they achieve success. So first, a little bit about the ecosystem. I said we're going to talk about metal, but we'll start by talking about all of our stuff together. So Markforged is a 3D printing OEM. So we ultimately we sell printers. That's kind of what we benchmark ourselves on. But a printer is just a box by itself. You need materials to print, and you need software to operate it. And so one of the main benefits of additive manufacturing is that it's Industry 4.0 by nature. Instead of having to use CAM or build drawings or doing things, you're just taking CAD information, you're uploading it to software. That software is generating machine instructions automatically, it's sending them to the printer automatically and it's printing the part. Now, seems simple. There's a lot of complexity there to achieve a level of reliability and part quality that can actually be used in real manufacturing operations. And so what Markforged has specialized in for about 10 years, which is how long we've been around, is really developing all three of these things concurrently. So we make our own printers, but we also extrude all of our own materials. We primarily make FFF or FDM-based machines, so filament out of nozzle. And we also have made our software from day one. So we've had cloud software since 2013 when we first launched. When we first started, basically everyone who did additive manufacturing in any way basically had a desktop application. You downloaded onto a USB, and you stuck the USB in the machine. We've been kind of all online ever since. And so that kind of native process enables us to very quickly improve our machines. Because our machines are connected, we push out over-the-air updates every 2 weeks or even every week for newer printers that improve the machines while they're sitting at your desk. It also enables us to put out new materials regularly and ensure that they're printing at a high quality on the machines. So we have both we go from plastic to plastic and carbon fiber to metal machines. And so the plastic and then the metal are different machines. So we'll focus more on metal today, and Ross will talk a little bit about that and that process.
Great. So we use this process that we call metal FFF. And FFF is one of the most mature 3D printing processes. It's basically a filament spool fed through a nozzle, like a hot glue gun on a gantry system, and you build parts up layer by layer. And we had the approach of saying, hey, what if we could do this with metal? What if we can remove some of the barriers with existing metal 3D printing technologies and build on top of the skills that customers have developed using our composite FFF 3D printers? So the value prop of this system is safe, affordable, and easy to use. And we'll get into how the technology works, but safe is the first one to hit on because there's no exposed metal powder, meaning no respirators, no hazmat suits, no explosion-proof rooms that you need to deal with. Affordable, existing metal 3D printers before the Metal X were roughly $1 million to $2 million. We brought that cost down to nearly $250,000. And then easy to use. I kind of built on top of this that a lot of customers have been doing plastic FFF for a couple of years. You can build on top of that knowledge and use this process very similarly to how you use the plastic, but with metal. So it basically consists of a 3-step process. And what we did is we married FFF 3D printing with metal injection molding. And this is a pretty common manufacturing process for very small metal parts like brackets on eyeglasses or little components on your iPhones. And what we do is we first print with the filament, and this filament consists of 3 ingredients: metal powder, polymer, and wax. We blend those together, and the polymer makes it flexible so that we can wrap it up into a spool and extrude it through a nozzle. And then the wax keeps that bound together so the powders don't come exposed to the operators using the machine. After you print the part, you put it into a wash, and this is a solvent debinding system that basically just is a degreaser and dissolves the wax out of the part. And then finally, you bring it to the sintering furnace. It's kind of like the analogy of clay. You mold it, and then you put it in a kiln to make it hard. Same thing with this process. We heat it up to a temperature that burns out the polymer. Now we just have the metal powder left over. And then we heat it up to the sintering temperature so those metal powders fuse together, and you end up with a dense metal part. So it's 3 separate stages of this process, but very light touch points in between each one. And I operate the system every single day. And it's not very disruptive for my job at all. So we want to talk about the strengths and weaknesses, right? We should be celebrating what this process is great at, but we should also be aware of where the limitations are and where some other technologies or manufacturing processes might make more sense.
So to understand strengths and weaknesses, you kind of have to understand what type of parts this thing produces. So typically, these parts have what we call open cell infill. So basically, the parts print, if you're familiar with plastic FDM printing or FFF printing, parts generally print with a roof, a floor, walls, and then a triangular or a hexagonal kind of micro structure inside the part. Some parts can print solid, but that's kind of the default across most types of 3D printing. Ours is no exception. The default parts have that kind of triangular structure. That being said, we can print solid. It's just not the default. Also, because of, as we talked about in that sintering process, the parts when you design the part and then upload it to the software, it automatically scales it up about 20%, depending on the material. And that accounts for a design shrinkage that occurs during during the sintering process, because essentially you have a lot more material in that part that's not the metal. The end metal part is smaller. So that's all done automatically. Because you have that scale up and shrinkage and that open cell infill, it does actually change what types of parts end up working really well. So across the parts that work really well, we see that the biggest strength of the Metal X and metal FFF printing broadly is that it can fabricate low volume, high mix parts with remarkable efficiency. So these aren't parts that you would typically see from like DMLS systems or powder-based systems where they're kind of ultra complex, or they have these weird features that they look really cool, or they go on a jet engine but aren't something that you might use day to day. They're just standard parts that have some geometric complexity that make it difficult to machine, or something that has high variability part to part. If you need something in a bunch of different configurations, it can be really painful to have to reprogram your machine all those times to just alter a single feature of a part. So we like to say like 1,000 to 2,000 parts a year. It's really broad depending on the size of the part. But the key thing here is the machine itself isn't that fast. In fact, no 3D printers by themselves are particularly fast relative to something like stamping. So the typical part volumes you're looking at are much lower. But it does do things quickly when you think about in the context of a general manufacturing process. So when we think about how our customers typically make parts, someone can machine a part in an hour or two. But the reality of getting that part in hand is never that. It's either they have to put their part in an internal queue and they have to wait for it to get done, or they have to send it out to a job shop and they have to wait for it to get done. So this basically brings that in-house, enables you to have a lot more autonomy over when you're making the parts. The second thing is related to this kind of low volume, high mix geometric complexity, is that it unlocks design freedoms in an interesting way. So there's no tooling cost when you're making these parts because the parts are the finished part off the machine. The complexity inherently, whether it is kind of complex faces, curves, these things, is free. Like a blocky part is no more cheaper to produce than a complex part. And as a result, the machine is pretty adaptable at making a wide variety of geometries. So things that typically would be a big no-no to machine are actually things that are printable without too much trouble. And the last thing we talked about, which I won't spend too much time on, is fundamentally it's really accessible for most facilities. When you look at most metal 3D printers or most large printers in general, you're starting to look at a dedicated operator. So the core benefit of 3D printing, which is that it's really easy and simple to use or anyone can use it, starts to go away when it comes to metal printing. This machine's an exception. You don't really need a dedicated operator. You can have a series of people who are trained on it and they can just operate it when they need to. It's lights out, it works overnight, it works over the weekends. It's a super reliable machine. You don't need to look at it. And it's a simple software. So the same software that drives our cheap plastic printers drives this printer as well. So those type of things really make it something that you can go from starting your printing journey with a plastic machine going all the way to being able to print metal without actually being too disruptive to your learning and your manufacturing workflow.
Yeah, like at the end of the day, I think of 3D printers as a tool that empowers engineers to solve problems themselves, where you don't need to rely on machinists, you don't need to rely on a third party. If I have a design file, I can go ahead and fabricate that myself. But there are some weaknesses to this technology. And these are things to be aware of because you would never CNC a sheet metal part, right? There's certain parts that you don't want to 3D print because it's more efficiently to make in alternative processes. Starting with like high volume, low mix. Like stamping, injection molding, those are super optimized processes that can produce parts in seconds and might take you minutes to produce a single layer of a 3D printed part. So there's some opportunities to scale up 3D printing because they scale very linearly. If you want to double your throughput, you just double your 3D printers, right? You can start printing on 2 machines at the same time and get twice the output. But you have to balance that with cost effectiveness. And if you're trying to make 1 million parts per year, you might need 50 machines to do that. And then all of a sudden, the ease of use kind of goes away. Precision tolerances is another thing about this system that we're just not really ever going to be able to achieve what you can get with like grinding with tens of thousands of inches. We compare these to cast parts in general. So, kind of a rough surface finish, kind of around 1% tolerance range, depending on the size of your dimension. But alternatively, these parts can be post-machined. At the end of the day, it's just a different process to get you the shape, but you can grind it, you can machine it, you can heat treat it, you can weld it, you can polish it. It's a steel part. And then there's like a spectrum of the size of the parts. And I typically say like thumb to fist size is the ideal sweet spot for the system. The larger you go, the longer it's going to take you to print, and there may be some benefits of other processes to make larger parts if it's going to take you 7 days to print a part, for example. And then tiny parts, well, we're constrained by the diameter of the nozzle. It's like painting with like a fine tip Sharpie versus a thick tip Sharpie. You know, you can only go so high detail. So the resolution of the nozzle, it's like 0.25 millimeters. You just can't go smaller than that. And that's something to be aware of in your design process. This is kind of just like a table to summarize what's like the ideal, and then if you want to push the limit in perspective of part size, tolerance range, current part cost, lead time. You know, we can make parts in few as 2 days, right? But ideally, if you have a part that's taken more than 2 weeks, you can almost always get that quicker with the Metal X. And then functional requirements. So we always compare kind of our metal technology with our composite 3D printing technology. And composite is good to have a very wide range of applications. And it's a single step, and it's usually cheaper. You know, plastic's just cheaper than metal. But the thing is, when you have parts that have requirements related to heat, related to wear, related to corrosion, or electrical properties, you're gonna need to turn to a metal, right? Like, you only use steel when you need to use steel. But when you need steel, you kind of have to use steel. And that's why we have this within our product portfolio.
And there's one other benefit that we think about that actually kind of goes against conventional wisdom. You know, when I first started at Markforged, one of the biggest things we heard from potential customers was, what are my machinists going to think about it? What are my employees going to think about bringing this thing in? Like, at that time, especially, you know, 5-10 years ago, the common narrative was 3D, like, you know, automation was going to take people's jobs away. I think now we start to see that now there's just not enough people to fill the actual jobs. And so automation is a way to actually extend people's reach further. And so this is a great example of how 3D printing can empower employees. So this is a company called Caldwell Manufacturing. They're out of, I think, Buffalo. They make windows and doors, and they've been around for about 130 years. And so they bought a metal system a few years ago. They've been using it ever since. They use it for everything from prototypes of small pieces of hardware to big tools. They also have our composite printers. But one thing they saw was top down. They realized that this thing fundamentally changed how they were doing business and changed how their employees were attacking problems. So we think about this, they talked a lot about removing bureaucracy and basically empowering their employees to solve problems as they came up. And this was at the top of the organization, the president saying this. The directors of engineering talking about how their engineers were fundamentally more engaged because when they had an idea for something, they could suddenly execute it, whether that be in a metal or in a composite. And then probably most importantly, to me at least, was the model maker who'd been there for 40 years, who originally, when they brought the printers in, was scared that these were going to obsolete him, and now is the machine operator, operates the printers, and is the go-to expert on how to design for them and how to post-process them and all these things. And actually, like, is now kind of totally up-level his skill set, because these printers are not that difficult to use. In fact, they're fundamentally much easier to learn than a subtractive manufacturing machine. The issue is just there's not as good education out there unless you get it in-house. So yeah, now we're going to go through 2 case studies that are kind of 2 Markforged customers who've kind of lived the additive journey and changed a way that, like, opened up a new door that they didn't expect to open, or kind of changed how they do business. So yeah, the first one is talking about how 3D printing enables high volume manufacturing. So you know, when we think about how people think about implementing 3D printing, they often first go to end use parts. How can I produce lots of parts at volume with a 3D printer? And like, the truth of the matter is, at this point right now, there's 1, maybe 2 technologies that have a good shot at being able to do that in the next 5 years. But the vast majority of 3D printing technologies, while really effective for businesses, are not something that's going to make end-use parts at high volume with like better than like the existing machines out there. It just isn't really the case. But what 3D printing has matured to be able to do is it's matured to enable and be a catalyst for faster production and tooling up of high volume manufacturing cells. So this is a good example of that. So Lean Machine is a metal shop in Saskatchewan. They're about, I think, 20 people in total, but they punch way above their weight in terms of the types of jobs they take on, the types of problems they take on, and from their budget, the actual output they're able to achieve. So for them, taking a fully tooled up automated bending cell and bringing it in-house would be completely infeasible. It's just too expensive, and they weren't able to do it. But they did get orders in of tens of thousands, hundreds of thousands of parts. And so what they would do is they would take one of their very skilled operators, and they'd ask him to actually operate the press brake manually. And this was super unproductive, but it was the way that they were able to answer the business they could before 3D printing. And so what they saw was that they were burning out their machinists. They were actually not producing parts at a high enough acceptance rate, and they were just fundamentally not making the revenue that they thought they were going to make off the jobs they had. So their end goal was to take, the result, which is a manufacturing cell that automates this, and make it themselves. And 3D printing was really the big thing that unblocked them, because without 3D printing, they had spec the time in producing a manufacturing cell flexible enough to do these parts at about 12 to 18 months, maybe even 2 years. And with 3D printing, they did it about 6 months. So, next slide. So, the way they did it essentially is by breaking the problem into requisite parts, and then using additive manufacturing as a catalyst to solve problems by printing parts that would normally need to be machined or sent out or any which way. So they broke their problem in making that one widget we just saw into 3 steps. First, loading the blanks into their press brake. Second was moving them into position, and then third was actually forming them. So the first thing they did was they took basically just a standard shelf and built a modular loading solution from scratch. So all these outlined parts on the right are 3D printed parts, and this is with our polymer and carbon fiber solution. But just an idea, so they basically designed this custom tray from scratch where they could load blanks very simply off the machine, and they have 2 of them so they can use continuous operation. They built all of the kind of hosing brackets, the hard stops, and all these parts, and I think it totaled about 30 to 50 parts on this whole assembly alone. Without this, they would have had to either pursue some off-the-shelf solution that would have been really not optimized for what they did, or they would have had to machine all these parts manually, and it would have taken them about a year to build this just by itself. So all these trays and all these bays are kind of enabled by the 3D printing themselves.
And like the same person who designed all these parts fabricated the parts as well, which is pretty powerful.
So then the next thing is how do they move the parts? And so this is actually an interesting design problem for them. They tried off-the-shelf grippers, and they found that the reliability wasn't high enough. So what they did is they just designed a custom pair of steel grippers. And so these are 3D printed on the Metal X. They've worked for about 200,000 cycles, and they're still working strong. But actually, the interesting thing here as well was the grippers weren't all. Often we talk about end-of-arm tooling grippers as a killer application for 3D printing, because they kind of answer all those things that 3D printing is good at. High geometric complexity, low volume, typically need to be a hard and strong part. But interestingly, they had tons of other parts that were involved in the actual moving that didn't need to be metal, and so they printed them out of composite. So this actual the wrist of the robot is a composite printed part. This part that holds the air hose to clean off the parts at the end is a composite printed part. So they have all these different parts here with the metal part needed for the durability and the composite parts that enable that. And then the last thing is that they actually, then this was a surprise to us, frankly. We didn't think that this was really possible. But they ended up 3D printing bending tooling, and as they claimed, it outperformed their tool steel. Now, that is a huge caveat because it is just not as durable. But what I will say is that the bending tooling they were able to print was really cheap, and it was non-marring. So they're forming aluminum parts. So they were printing. They had A2 or D2 bending dies, and they were fundamentally marring the parts. And so they basically had a crazy idea, decided to try to print them. They went through about 8 iterations in a week, and they ended up with a set of bending dies that they can use to actually bend parts. They work for thousands of cycles, and then when they stop working, they just unbolt them and put the new ones on because they can just print them while they're working. So it's a totally parallelized process that enables a ton of customization. And so when you add it all together, and you look at the bending cell they built for far under budget and about a year faster than normal, they have about 50 or so functional parts, and they are constantly adding and changing new parts to that. So if they see an opportunity to upgrade, just like you would have a new software version in your automation software, they just print a new part that enables them to do something new.
We always appreciate these companies that are willing to let us speak on behalf, because this is their competitive advantage. This is how they can be faster and cheaper and more attractive to the companies that want to pursue business with them versus the competition, is that they have these 3D printers at their disposal to tool up lines and start producing parts quicker than anyone else.
Yeah, and I want to highlight a couple other things here. So the first one is we talk about metal and composite printing as things that solve separate problems. They actually can go along the same steps to solving the same problem. So before they had their metal grippers, they had actually prototyped the whole thing with composite parts, because these composite parts they can get in about 8 hours, and the metal parts take a few days. So they were able to kind of test a bunch of different geometries. When they found a geometry they liked, they selected the metal part. And actually have here the next generation, which we don't have a photo of, but is on their machine now, which is a hybrid tool, which is lighter than it has kind of the tool body of the composite and a tip of the tip of the metal tool. And that's lighter than the existing tool, but still has the same wear resistance they needed. And then the last thing is that we talked about this as if they were solving one problem. They actually, as they were tooling this up, used it to solve 2 different manufacturing problems simultaneously. So this single press brake thing that they designed and built from scratch actually was built to solve 2 different jobs for 2 different widgets. And they could add another one if they needed to. They could swap it out pretty easily. It's super flexible. So we talk about what happens when a job ends. They already kind of they thought about that when they designed the system, and because of the flexibility afforded to them by 3D printing, they were able to kind of account for that before the end of job even happened. Oh, yeah, and here's the video. I think this is very slowed down, but
Did I click? No.
oh, it did not work.
Are you able to click on the computer?
Maybe. Oh no,
Bummer.
that's fine. We can show you later.
I think you get the idea.
It moves
Picks
it
things
around,
up,
it
puts
bends
down,
it, you know.
Bends it. Okay, so turn the page onto a new case study, and this one's an interesting one because it's actually counterintuitive. It's subtractive manufacturing working with additive manufacturing. Not something that seems too obvious, but actually turns out to be a killer application with our technology. So Goering, they are one of the largest OEMs for cutting tools, and they specialize in a lot of different shapes and sizes and materials. And they care so much about efficiency and customer satisfaction. A challenge that they were facing in their business was that they had these key clients that were coming to them with very special requests, that they want this certain tool that isn't in their catalog that was more efficient for the operations that they're doing. And Goering wants this business. They want to continue to grow with these customers, but it was cost prohibitive to both the customer and the company to pursue this because, we're talking like tens of thousands of dollars for these tools that sure might be able to be justified over a long time span, but didn't make a lot of sense to detract resources into these projects. So there was a lost opportunity cost, and also the expansion of key accounts that they want to continue to do business with, they really want to approach. So the end goal is to be able to address these type of requests and create these custom milling bodies using 3D printing as a solution to both lower cost and lead time and enable that customer satisfaction. But something that goes beyond just the ability to 3D print these type of milling bodies that's on the left, which by the way, the entire part itself is 3D printed, and then they just braze on the carbide tips for high wear resistant. But an important factor with CNC machining is the coolant fluid and the ability to remove heat as you subtractively manufacture chips off of the part. And there's 2 different ways to go about the coolant. One way is to have a little hose on the outside of the milling body and spray the coolant onto the part. But then there's some innovation that has come up with doing in-spindle coolant, so actually having the coolant run through the tool itself so it's getting close to where that heat's being generated. And 3D printing, we mentioned, offers this new array of design freedom, knocking down all these barriers that we associate with linear drilling and setups and pockets and things that you can't access. So you might notice a kind of funky feature with this tool right here is these little diamond holes on the side. So 3D printed, built up layer by layer, it needs supports when there's angles more acute than 45 degrees. So oftentimes you see these holes that are diamonds instead of circles because they're actually more efficient for the 3D printing process and doesn't need that support material to generate. What they were able to discover, they approached this project saying, we want to reduce costs, we want to reduce lead time so that we can make this cost effective for the customer. But then the designers who were familiar with the 3D printers realized, hey, we can take this a step further and actually go into optimizing the efficiency of this type of job. So these coolant channels actually navigate in this more organic path and shoot out the coolant where the most amount of heat is being generated into the part, as opposed to traditional manufacturing where you drill a hole, you drill another hole, you hope they line up, and you kind of accept the location for where it is, even though it may not have the best efficiency. So you look at the cycle time difference between Out of spindle and in spindle, it's like 44 seconds compared to 20 seconds, but they got down to like 12 seconds with this more optimized path. And now they have like this new paradigm shift with breaking the catalog and these made-to-order parts now. Instead of having a single job on a single CNC machine, they can have a digital file that becomes your source of truth and print all sorts of different configurations of these tools at a single time and come out with all sorts of different design variations and, you know, taking the steps of adding the conformal coolant channels, offering value that couldn't be realized with traditional manufacturing. And it works, right? Like for a lot of people, 3D printing, it's like this bespoke technology. Many people, it's like metal 3D printing. Wait, that must be science fiction. Like, is that happening today? And just like showing the fact that yes, you can cut aluminum with a steel 3D printed part is, you know, a large step for a lot of companies. They do require that post machining I mentioned, like casted parts, but it's just a finishing operation. You just need to kiss the part to get to that precision tolerance. Add your carbide tips on, and then start milling. Here's kind of like a video of it in action. You can kind of just see the efficiency of the coolant spraying out of the part and just running through that, you know, roughing through the part. I printed one of these myself. I'm more of a 3D printing guy, but I do like to step on a Bridgeport every once in a while, and yeah, I've milled a few parts myself. Now, if we take a step backwards, the only reason that this was realized is because they went on this journey with additive manufacturing. There's always got to be that catalyst to bring the technology in-house. What we realize is once you bring the technology in-house and the engineers get familiar with it, they start using it for applications that you could never even think of until you have that type of connection between you and the printer. And they first prototype these in onyx, our plastic material, to make sure it fits right, to make sure it's accessing the pockets, to make sure you have the right clearance for the carbide tips. And then that's when they had that light bulb moment that we can put the coolant channels into the part, and then they can actually run the coolant through the onyx part, you know, check that box that it is running in the right direction. And then you can go into your tool steel part, because it's going to cost more, it's going to take longer, so you want to make sure that you have that design as validated as much as you can. And how do you validate designs? You design it, you machine it, you test it, and then you iterate. And you go through that feedback loop. And the more iterations that you can go through in a given amount of time, the more optimized of a design you get at the output. But then there's also like these secondary process improvements that, again, you can't really think of until you bring the technology in-house and add in additional value to your customers and understanding the pain points that they have and actually being able to address those with solutions. So small little things, just like these little casings that go around the tool. Like these are expensive tools, and the carbide tips are very brittle, so if it falls on the floor, those will break, and they're brazed on, so it's a large rework operation. So they can start using the onyx material, the composite material, to print these cases that are conformal to the strange body that it's in, and protect the tool when it's not being used, when it's in transit, and just increasing that customer satisfaction to create more stickiness with the business and be the leading OEM that the companies want to continue to work with.
Yeah, so we just want to close this with a couple things. You know, what do we think you should be asking yourself about additive right now? So the first thing is, what are the pain points in your manufacturing process that are unaddressable by kind of standard means? What are the things, what are these problems that you've kind of accepted as a part of your manufacturing process, but you understand cause you pain on a regular basis? And how do these affect your company? You know, on a day-to-day basis, are you scrapping parts more often than you need to? Are you relying on a third-party supplier too often? You know, are you printing prototypes but only fit check prototypes, not actually functional prototypes, and then getting to the end part and realizing it doesn't actually solve the needs you want? You know, next is, what are your required capabilities? Like what in a 3D printing solution actually is required? A lot of people enter 3D printing assuming that they want to print the same material in the same way that they typically manufactured subtractively. The fact of the matter is there are fewer materials that you can additively manufacture than subtractively manufacture, especially with this process. We have 6 materials. So the question is, can this machine solve the problem? Not can you exactly match the capabilities you had before. And the last thing is, how will you measure value for your printing investment? You know, this is something where if you've integrated additive to a point now, you understand that additive generates value in a very different way than subtractive manufacturing generates value. Whether it's that kind of unknown value, kind of unleashing your engineers on a wide variety of problems, to like fundamentally insourcing parts. So you're manufacturing parts in-house instead of out-of-house. The costing is totally different. So all these things are really important towards actually generating what would be success with additive. But at the end of the day, just like some of the presenters earlier said, a lot of it is just being willing to take that first step and try it. That's what a lot of our most successful customers ended up doing is, they found an ROI they thought was compelling, and they believed in it, and they just took a step, and that's why they are today.
So that's what we got. Hopefully opened your eyes to some things going on in the background with 3D printing. A lot of people approach it thinking like, we need to print this end-use part. But if you have the realization that you don't need to print the final part, you can print the tools that lead up to that part, you can still make that part more efficiently. And if you're making anything, there's room for a 3D printer within your organization.
We also have some take-home parts because we'd be a really bad additive manufacturing company if we didn't have parts like goodies, So
we'll pass those out. But any questions?
No, that's like a marketing screen. Normally it has a pretty nice device screen. You can actually see all the telemetry of the machine. You can do job queuing from a computer to the actual machine. So if you have an operator and an engineer, but yeah, it's they like the start because it makes it feel like a race car thing.
Let's get started.
Any other questions for these guys back here?
Super cool, guys. We're a greedy and geeky society, so always want to know what's next from a iterative or evolutionary thing. What's next? What are you guys working on? What's the next feature, the next sexy thing that's coming out for printers?
So we kind of touched on the beginning of the presentation that these are connected to the cloud. That's actually very unique from a machine hardware perspective because we can actually push updates over time that add value to the machine. So rather than it depreciating over time, it appreciates because when you bought it, it didn't yet have features that were later available. So my job as the product manager is to kind of forecast what can we do in the future with the system that's already out there. I like to take a very much application focus. So I want to improve on existing applications and expand the scope of addressable applications. Improving means, can we print faster? Can we print higher detail? Can we print parts that used to not be capable, but if we slow down the print speeds, we can print finer details. And then new applications means new materials, new stainless steels, new tool steels, new coppers, new Inconels, new material varieties. So it's my job to kind of look at the industry and see what the current state applications are and then where we could go in the future. But then there's some other technologies that we're investing in. And recently we acquired a company called Digital Metal, and they use a process called binder jetting. It's kind of like 3D printing versus additive manufacturing. So this isn't like a turnkey solution, not as easy to use. There's a lot more R&D that goes into producing a part. But what it's capable of is producing millions of parts per year. It's like, we kind of hit on like the biggest drawback to 3D printing is these high volume applications. But you get all the design complexity. And now if we can speed up the process, this is why I think we'll take 3D printing from 0.1% of the manufacturer market to like 1% of the manufacturer market is going into those production high volume applications. So that's probably the next big thing that we'll be looking at in metal.
You had a question in front?
Yeah, it's a similar question. More the time frame into the more design tools.
You mentioned Inconel and things like ceramics and carbides in terms of being able to print those.
Yeah, so we got A2, D2, and H13 right now. So it's a pretty comprehensive list of tool steels. S7 gets asked for a lot. I kind of hesitate to add a fourth tool steel in our portfolio. I think that it's a pretty good amount. So if you have other materials, though, I'd love to talk to you and figure out what type of applications we can solve with it, because that's definitely one of our growth vectors is adding new materials that are compatible with the system over time.
A lot of it's like business-based as much as technology-based. These powders exist, and the process is stable from powder to powder. It's just what order of materials generates the most value for our customers? We talk about like the sexy stuff, but a lot of the stuff we've been doing for the last 3-4 years is the unsexy stuff, which is taking a product from something that just was launched and is a nice box that makes parts successfully, 60% of the time, to something that works lights out. And that's a long and arduous process with 3D printing. It's a process that our company has kind of hung its hat on, as we always wanted to be the reliable ones. But that is those are kind of the things that we think about when we're making a decision. We just relaunched our most popular material, which is 17.4 pH, because we realized that by reformulating the material, even though it wasn't a new material, it would actually add the most value to our customers by the new things that we can unlock going forward. So we try to think about the problems in that way.
Yeah, that was an interesting one. Like 17.4 was the first stainless steel that we launched. And I said at the beginning, like we're mimicking metal injection molding. So we took a metal injection molding formula, applied that to 3D printing. It got us pretty far, but then we learned a lot along the way and we figured out we can change up those ratios of the binder. It became a lot more like flexible, and that was a big pain point for the customers is the spools would break if they didn't handle them cautiously. So taking a step back, it's like I want to take care of the customers first, deliver the best value and user experience. So we reformulate rather than launch a new material in the short term.
Automotive has always been a little hit and miss over the years. With the plethora of EVs and new models, do you see more opportunity?
Yeah. The killer application for 3D print since day one has been prototyping, and it continues to be a great aspect. Like any engineer in the room would probably agree with me that there's this intangible value of getting a part off of the computer screen and holding your hand, turning the machine on, and then making sure everything's working correctly. And if it's not, being able to tweak that before you go into production. One unique material on our portfolio is copper. This is a pure copper, not a copper alloy. So in electric vehicles, we're seeing huge influx of prototyping applications with this copper since it's such a unique material. On the assembly line, though, there's explosion of applications there. Where there's smoke, there's fire. Where there's robots, there's opportunities for 3D printing. Every single welding arm, pick and place, gripper, all those things, it all used to be aluminum. Now it's our black onyx or stainless steel material.
Yeah, I would say if you invest in a robot arm, like it would be almost criminal to not have a 3D printer capable of producing a strong part for it, because the flexibility you're inheriting is supercharged so much by being able to make end effectors, tools for that arm that actually increase the type of task, that increase the number of tasks it can actually accomplish. Any questions?
Okay, last question.
All right.
This one came online, and I'm sure everybody else is wondering too. Typical investment for a Metal X with the wash station and the furnace?
Yeah, you're gonna want budget. Let's call it between $180,000 to $300,000. There's different configurations, different sinter and furnaces. Installation is quoted differently from our resellers. So that's kind of how you want to think of a budget for a Metal X printer.
The one thing I'll note is that the wash is a parallel process. So it's just a solvent bath. You put parts in, you put parts in, you take it out, and the actual time it takes to wash is basically dependent on the size of the part and the thickness of the part. The sinter is a batch process, but it has far more throughput than the machine. So you can support we have two furnaces, a smaller one and a larger one. With the smaller one, feel pretty confident that you can support 3 printers running full bore. With the larger machine, you can support 5 printers. So what we actually see is, you have to buy one of each to get in the system. But then we have customers who really like the machines and end up using them a lot, who'll just buy more printers, and the wash and the sinter will support the use of those. So yeah. Cool. We have some parts. We'll wait till the next break to give them out, but yeah. Yeah, for sure. Perfect.
So we got one more for our break. And yeah, so we're really switching directions now. We're going to talk about artificial intelligence or AI. Not only to get a grasp on what AI means to manufacturers, but because I don't really know how AI is used in manufacturing right now, but we're lucky enough to be able to be here from a company that's already begun adopting AI in its operations. So our first presenter, who's going to kind of provide an overview on AI for manufacturing, is Joe Bashta. Joe is CEO of Axicor North America, which is an AI solutions company, and he's going to be presenting remotely, so hopefully we'll get him up on the screen here soon. And like I said, he's co-presenting with one of his customers here. So Joe takes his customers on data journeys that begins with extracting value from the data they already have, or what they call business intelligence, and then moving into predictive and prescriptive analytics as measurable outcomes are achieved at each stage. There's Joe. And I'm grateful again that one of Joe's customers is here. He's going to share his adoption of AI. And while it's not a metal forming company, I'm sure the story that we'll hear from Brian Schaaf will be quite interesting to everybody. Brian is the Innovation Technology Program Director at Schreiber Foods, which is right around here somewhere, right? Green Bay. In Green Bay, okay, right. So he's worked for more than 20 years in technical leadership in various manufacturing and services organizations, using technology to create a distinctive competitive advantage. So please welcome Joe and Brian.
Thank you. Hey, Joe, it's all yours.
All right, thank you. Let me just do an audio check. Is it coming through okay?
Yep. You are perfect.
All right, let me share my screen. Kick off. Okay, is that on the screen?
Yep.
All right.
Yeah, you're all good, Joe.
All right, thank you. So I'm just going to do an overview of the data analytics journey and then explain how AI gets its intelligence. And then I'll talk about some of the challenges with AI adoption in the marketplace, and then address how we address those challenges. And then I'll introduce Brian, who's just been introduced, to talk about some examples in the industry that he works in. And we'll close out by talking about what's actually out there in terms of applications, vendors, and how do you know what to buy. So as you can probably imagine or guess, the overview of a data journey starts with the obvious thing of what is the business objective. So we work with our clients to define the objective, the scope that you're looking for, and particularly what's out of scope. And then we look at what are the expected outcomes or deliverables. We then collect the relevant data points to achieve that objective and outcome. And that third column of descriptive analytics is what we call business intelligence. That's what most of us do intuitively in our companies, and I'll talk more about what that actually entails. Once we complete the business intelligence, we then look at the predictive analytics, the modeling of it, and we test that through multiple iterations. We then validate that with the business against the objectives and then implement at the appropriate time. So that's a really simplistic, high-level overview of the journey of analytics. So in terms of business intelligence compared to artificial intelligence, BI looks at historical. It looks current and historical. So what's happened, when, how many, and it's really reactive. So bottom left-hand corner, it's reactive. Contrast that to artificial intelligence, which bottom right-hand corner is preemptive and proactive. So it takes the insights from business intelligence and that generates the foresight. And it does that by looking at the future. It tells you what will happen, how will happen, why, when. It'll look at some of the hidden trends and patterns in your data and give you some of those relationships that may be not obvious because we swim in an ocean of data. We're overwhelmed by it. So that's the high-level differences between BI and AI. Once you get into artificial intelligence, there are two camps, the predictive and prescriptive. And again, at the highest level, they do the same thing. They tell you the likelihood or probability of an event occurring. But prescriptive goes further and says, now that I know the event that's going to occur, let me tell you what the outcome will be before it occurs. And now that I know that, let me tell you the consequences. And then lastly, as the name suggests, it prescribes to you the recommended actions that you should take to either avoid or achieve the event, the outcome, and the consequences. So that's prescriptive versus predictive analytics. To put that in the context of a manufacturing environment, in this example, you have 3 machines. There's data being collected on all of those machines. And there's a predictive analytics model or program in the system, and it predicts a failure. It says machine A will have a circuit breaker activation in 2 hours. And it tells you why. Because it's going to exceed a threshold that you've set, which is the waveform distortion. So that's something that you set. So predictive analytics will stop there, alert you to it, and you step in as the operator to address it. However, if you have prescriptive analytics, It says, well, now that I know the likelihood of that event occurring in 2 hours, here's what I recommend. You should delay forwarding job 23 to machine C by half an hour, and then start job 45 on machine C instead. So at this point, it stops and it watches what you do. If you ignore both of those recommendations and do option 3, it'll watch what you do, catalog it, learn it, and bring it up to you again. If the exact same scenario occurs in the future, it'll bring you 3 scenarios, or 3 options rather, the 2 that are recommended and the 3rd that you actually executed. So that's what predictive analytics is. It's driven by machine learning, which I'll talk about. Machine learning is simply software that learns in a continuous loop. So how does it get its intelligence? And I've just really answered the question. The key to artificial intelligence is what we call machine learning, which is software that learns. So contrast that to traditional programming way back in the 80s when Bill Gates, Microsoft created traditional programming. They had the input, created the program, and out came Microsoft Excel, PowerPoint, and so on. Traditional approach. So contrast that to machine learning, which does almost the opposite. It learns by looking at the rules and the examples you give it. So here's the input, very similar to traditional. However, it says, what does the input actually mean? What do you do with it, and what should I expect it to behave like? So once we tell it the output, it then creates the program to achieve the output. So slightly different in terms of its approach. So again, to achieve that, we use what's called supervised versus unsupervised models. So compare that to, say, for example, a classroom of students where they have supervision by a teacher compared to a classroom of high school students that have no supervision or teacher. So in this context, on the left-hand side with supervision, there's methodology, there is structure and format to the learning, and so there's more accurate, reliable outcome. It's more trustworthy because we give it information. We label the data. Label means, imagine a spreadsheet. At the very top, you have the rows, date, name, time, address. So that's a label or a data point. We train it through algorithms, and we handhold. The exact opposite is true of unsupervised. And I'll give you a couple of examples as we go through this. So the way machine learning learns, so I'm bringing it down to the most base level now to give you an idea of how it actually gets its intelligence. So this is a really good example that Google used. So they feed this is the input. They feed the machine or the software a picture of a cat. They train it to recognize the cat, and they test it. It passes. They give the same software a picture of the same cat facing a different direction. It fails. A 2-year-old would pass this test, but the software needs to be trained at the most basic level. So obviously, we continue feeding different pictures of the same cat, different angles. It passes all of those on the right-hand side. It comes up with a cat it's never seen, and it fails. So you get the idea. It's just thousands and thousands of the same thing over and over until it understands it's all a cat. Once you get to that level, then you begin to feed different animals, and eventually it learns to catalog through machine learning. This group is cat, this group is a dog. So I really oversimplified it, but I wanted just to take some of the mystique and the misunderstanding. This is really basic teaching of software that is intuitive and learns once it's been shown what's correct. Here's another example of exactly the same process, but instead of pictures, it uses documents and language. So here's a resume of John Doe. It recognizes John Doe resume, but not Emma Hayes. So again, same process, thousands of resumes being fed into the system, and eventually it recognizes what a resume is in different formats. So this was tested in, they're right down the bottom there, 1997. IBM developed its Deep Blue machine using artificial intelligence, and it sets a match, a chess game. Some of you may remember this, against the world's chess champion at that point, Garry Kasparov. And they used exactly what I just described, supervised machine learning. They fed into the software what the game of chess is, what the pieces represent, and the finite number of moves that you can play in the game of chess. And it let it learn by itself, and then against humans, and over a period of time, it mastered the game of chess. The outcome of that was Deep Blue, IBM's machine, beat the world champion 3-2. So that's an example of supervised learning. Fast forward almost 20 years after that point, in 2015, Google's DeepMind beat the world's Go champion. And the reason this is significant is because they didn't use supervised learning, they used unsupervised learning, which was a much longer process because of what I've described. And what's even more amazing about this, as down the bottom there, it explains why this is significant. The game, usually played in Asian countries like South Korea and China, presents an entirely different challenge because of the game's incalculable number of move options, which means the computer must be capable of human-like intuition to prevail. So completely different to the finite number of moves of a chess game compared to that. So that was 2015. We're now, 7 years on, so you can imagine how much more it's advanced. I'll spend a few minutes going through some examples from our own company. This is a college campus basketball team that wanted to know if we could use the wearable sensors they had to predict game outcomes and player injury as well. And so we were able to show them with the data they had what we could do. And then in terms of player injury, it's quite broad. So we needed to narrow the scope of what do they mean by injury and are they collecting that data. This is a utility provider in Australia, which is where the accent comes from. Even though I'm sitting in an office in Green Bay, I'm Australian. This is an Australian example where they wanted to know not only the peaks and troughs of consumption, but also the spare parts, because when you have substations scattered all across the state, they want to know what will fail, when it will fail, and why, so they could stock up with the appropriate spare parts. Another example in Australia, this is a research organisation with supercomputers, and they simply wanted to know, can we predict the degradation of the performance, peaks and troughs, and what are the users doing in terms of performance, because they were paying for that machinery per hour and they wanted to get the best out of it. And we were able to show them exactly what they asked for by predicting it. There are a number of use cases with the banking, too many to explain, but there are one in Canada and two in the US. Some are quite complex, but suffice to say, banking and healthcare have no shortage of use cases for AI. The two interesting ones for government, we were involved in predicting the likelihood of social welfare down the generational family cyclical behavior. So can we predict it, and can the government take preemptive steps to break the cyclical behavior of family welfare benefits? The other government use case was to do with predicting opioid addiction. So can we predict the likelihood of a county or a province, this was in Canada actually, the province being impacted by opioid addiction, and can we go further and predict the likelihood of a death from opioid addiction or overdose? And the answer to both of those was yes. And when we talk about prediction, we're talking about a level of accuracy. So whilst we can predict something, is it 20% accurate or 90% accurate? So whilst I say yes to some of these, the accuracy is immature and low until it begins to learn with live stream data over a period of time. This one, transportation, is shifting the industry from preventative maintenance to predictive maintenance, and even further into prescriptive. So rather than take the vehicle off the road to do a scheduled preventative maintenance, let the data tell you the behavior and the performance of the vehicle, the engine, the gearbox, and so on, and leave it out there. If it doesn't need to be pulled in, leave it. If it does, bring it in earlier. So moving from preventative to predictive. Healthcare, again, like I said about banking, many use cases. The one that really intrigued us was being able to predict the likelihood of a patient who's been released from hospital coming back to hospital into readmission because of an issue from surgery, for example. So can we predict the likelihood of readmission within 28 days of being released? Because if we can, that saves downstream impact on both staff and financial loss and insurance. So quite a significant use case. And the answer is yes, by the way. Manufacturing, again, similar to others, anything from procurement, raw material, all the way through to distribution. Any of those can be a use case in isolation, siloed, or integrated with the whole supply chain. And when you run ERP, it's much more easier to predict outcomes because there's so much data available through ERP systems. Telecommunications, very similar to the others, predicting peaks and troughs of usage and also outage. Safety first was interesting. We worked with Australia's largest steel manufacturer. They wanted to know, could we predict injury at the work site? Like America, we have to have recorded injuries, and they gave us 6 years of data of recorded injuries. We worked with that and were able to isolate where the likelihood of injury would occur, how frequent, and the reason why, the underlying root cause for that company. This is a group of casino operators in Argentina who wanted us to use the cameras they have in the casino to look at the likelihood of fraud at the tables. That didn't go anywhere, but it was an interesting use case for us to consider. This last one was a customer that wanted to know if we could predict the triggers that cause fluctuations in Bitcoin and Ethereum. And I was dubious, I was reluctant to take that use case because it's so volatile. But we took it on with the proviso that if we didn't meet a certain accuracy level, again, predicting to a certain percentage, we would give the customer their money back. He wanted 65% accuracy. We finally agreed on 45%, and we achieved 52% in our first attempt and 57% in our second attempt. Again, that's still really a coin toss. I wouldn't call that a prediction at 50 anything. Until we get to 80, 90, I wouldn't be using AI to predict the likelihood of Bitcoin and Ethereum staying stable. So at this point, let me share, unless there are any questions, I'll keep going and share some of the challenges that we've faced in terms of the adoption. So the challenges we've faced in the marketplace and feedback we get from clients is it hype or reality? And this is very, if you're familiar with Gartner or any of the research organizations, you'll be familiar with the hype curve and the quadrant. And so it's a valuable question and a fair question to ask, and I will answer it in the next slide. The other challenge we come across a lot is we're overwhelmed with terminology and data and infrastructure, and it's really also about unproven ROI or unproven returns. The next one we get is the fear of the unknown, the black box. And so wanting to know whether they're going to lose control, is the AI going to make decisions they're unaware of and don't agree with? And then the final one is, does my business even qualify? Do I have the data I need? Do I have the resources internally? I usually don't have a data scientist. Does that disqualify me? So these are the common challenges we get with adoption of AI. So in addressing that, I looked at Gartner's hype cycle just to see what they're saying at the moment. In terms of artificial intelligence, compared to other technologies, they find there's an above average number of innovations which reach adoption in mainstream within 2 to 5 years. That's really, really fast in terms of its adoption. So I guess the answer to that question is no, it's not hype, it's very much reality, and the adoption is accelerating. The black box concern, it's absolutely valid. It is a genuine concern, and there are many use cases out there where it has been black box. In fact, I've got a comment down the bottom here where it says it's even difficult for the designers of AI to explain why it arrived at a certain decision. So that's being changed now with industry trends where we're using what's called explainable AI. As I've got there in yellow, there's transparency, interpretability, and explainability. So white box means the machine learning models provide results that are understandable for us as opposed to just the experts. So that challenge or lack of adoption is now being addressed. This last one that's very common is unproven return on investment. So I have up here the logos of 3 companies, 2 of which I've actually witnessed as a consultant in the Midwest in Wisconsin to companies regarding AI. I've actually witnessed the return on investment on 2 of those 3. The first one, called Salonis, is really fascinating. What they do is take your ERP data and they visually map the process flow. So everything from procurement to distribution, they visually map that process flow and show you where the bottlenecks are or the breakages. And it looks like spaghetti bolognese. It's overwhelming when you see how much flows through the system. But what it does is isolate the anomalies and shows you where the bottlenecks and breakages are, and it quantifies them by dollar amount and time. So it says best practice in the world is X in terms of time to process and cost savings, and here's where you are. And it gives you the delta. And then it goes further and says, now that we've identified the root cause, the customer then goes to fix them, but then Salonis will predict the likelihood of that occurring again. So immediately, I spoke to the customer who's using this as a proof of concept and asked them, have they had ROI? And they were able to show me a spreadsheet with tangible, measurable return on investment, even in the proof of concept. So a very powerful use case. This next one, called Data Nomers, they use what I talked about in the previous slide called explainable AI. So their focus and specialty is predicting customer churn. Can you tell if a customer is about to leave you? Most of the time you get a gut feel in terms of relationship and ordering trend, how much they order and the frequency. Sometimes you lose sight of it. So Data Nomers uses your, again, ERP data and sales data to tell you the likelihood of a customer leaving you. So again, I spoke to the customer using this vendor and asked them if they had a result or return on investment. And they said they had two results. Firstly, that the vendor was able to validate their gut feeling that certain customers were about to leave. So it actually validated that. Secondly, it identified customers that they weren't expecting to leave, but the machine learning models did, with a high level of accuracy around the 82% mark, likelihood of customer leaving. So they were able to quantify potential return on investment by investigating both of those. The third one, called Intense Eye, I haven't seen it in practice, but their use case is quite a powerful one. What they do is use all the cameras you currently have in your building, and without any change to any hardware or software, they'll ingest that visual computer vision data feed from those cameras and tell you the likelihood of an injury or an accident or someone not following protocol in the factory floor. So again, the power of this use case and their technology is you make no changes. You simply continue using the cameras that you've got. They ingest that into their machine learning models and train it to look for incidents of injury or potential injury. So I share those three examples to make the point there is proof with return on investment using AI. So one of the ways we address some of those challenges is what we call the simulator. This is where we take some of the data that you have, we simulate a use case by working with you to identify your objective, your scope and your outcomes. We then look at taking some sample data from a spreadsheet or CSV file, and we simulate the likelihood of those outcomes in a sandbox which is not connected to any of your systems. So that's why we say there's zero risk. The idea of the simulator is for you to run numerous iterations of a scenario so that if you do go live with a decision, you've got greater confidence, you now know the outcomes, and there's realization on the ROI. So what you can use it for is a proof of concept, R&D, digital twins. Again, virtual sandbox, you can simulate a part or all of POC or pilot or R&D. Real data, meaning it's your data, we're not fabricating, it's actually your data. And sometimes that data is redacted, so there's sensitivity that's removed. You set measurable targets, you run unlimited what-if scenarios, test hypotheses, and discover unknowns and gotchas. How does it work? So we take structured data, unstructured, semi-structured, all the different types of data goes into the simulator, the machine learning models. We can connect to a data lake or a data warehouse if you have that, any other third-party software, and then we push the results out into whatever dashboard you may be using, whether it's Microsoft Power BI or Tableau or Domo. It doesn't matter to us. We're agnostic to that. When you finish running all of the models and you get the outcome that you are looking for, or at least some outcomes that you weren't aware of, at some point, if you want to migrate those results because you're confident with it, we can connect to production systems and migrate on the same platform that result. So in terms of what you get value for money, the business case is proven. You can eliminate, POC or pilot budget blowouts, data-driven results with measurable outcomes, and then migrate to a production system if you want to. And I think with that, I'm going to hand it to Brian to talk about some examples in his industry. Thanks, Brian.
Thanks, Joe. There. Can you guys hear me well? Okay. Thanks, Joe. You can actually go to the next slide. So I'll start at the next one. So I'm Brian Schaff. I work with a company called Schreiber Foods out of Green Bay. This is the Wisconsin accent. Joe is Australian. You'll understand later. So what I want to do is go through a couple of use cases and highlight some of the things that Joe went through. I've got a use case where we were very successful and the opposite. But at the end, there's a couple interesting lessons that hopefully we can share with you. We as a company are what we call data rich. We've got data everywhere. You can't help but step in data. But we are information poor. We've got a bunch of I/O and bits and bytes and things, but I've got very little cognizant what to do with it. And that's part of this set of experiments and this set of discussions we'll go through. So the first use case I want to go through is a blending unit operation for us, right? So take blue and yellow and you mix them together and get green. In our case, it was a food product and a very highly valuable flavoring that we would blend together to make a specific flavor profile for a specific customer of ours. That flavoring being a very, very expensive element that we don't want to waste and don't want to have go bad. So one of our problems in this case was we had a complaint. We actually had a series of complaints. And the way we got to judge the complaint was good or bad is people would have to taste it, right? So, which is like a completely qualitative, no, it's not qualitative at all, is it? It's qualitative, not quantitative, that's what I meant to say. It's a terrible way to measure is something good or bad. Because if you had like eggs for breakfast, how do you know something's going to taste good in the morning? So we wanted to get out of that, right? And one thing we would do, and I'm sure many of you all do, when you have a quality problem, you want to make sure that quality problem goes away. So we have a range that was plus or minus 10%, let's say, for our set point where we could be. So to get rid of the complaint, what do? You shift your set point up so the tail end is never right outside of that range. What you're doing is you're throwing away money. You're putting more expensive things in to never have a quality complaint. So we took a quality complaint and made it a cost problem, and that helped us quantify what we wanted to do. So we were looking for a solution that would tell us the root cause of why these deviations would happen. Our operators were saying one thing, our engineers were looking at the data and saying something different. There had to be some way those two things were the truth. And we wanted to find a way to automate out those errors and drive that forward. So we started using Excel. And another complication here, we got to a point where we made a really cool Excel model, like blinky lights, the whole bit. I would do one change and it would take 7 minutes for it to update. Then we had, do you all have a pandemic down here? We had that up in Green Bay. So doing that 7-minute update over like VPN, it made it longer than that. I gave up twice. I don't know. But so part of this discussion and this use case, I want to walk through some of the things we got through for those complications and how we address those problems. Thanks, Joe. So our initial results, what we would do in Excel was try to use a little bit of basic data analysis and follow that little process. If you guys are programmers, every know Hadley Wickham, he goes after this process on the bottom where you'd import data, you'd tidy it up, and you kind of iterate through it so you could find a decent model so you could visualize and then communicate what was going on, right? So we would use Excel to do that. And I'm looking, so we would have data. We have a historian system. You all were talking about ignition before. We have a GE prophecy system. We have an ignition system. We would take as much data as we could at less than second interval data for days, pull that into our model in Excel. Now you know why I broke it. And try to do something with it to find factors that were our cause. And we were really happy. In about 3.5 months, we found 3 factors that caused something to go wrong. But it took us 3.5 months on 1 unit operation for this thing, for us to find this. Again, I just want to say pretty Excel files, right? So what were our results out of the next step, right? So we decided to work with Joe and Axicor to use their simulator to see, can I go from where I was to a model and to find factors faster using an AI simulator and the machine learning aspects of it instead of the human learning aspects of it. And we were pretty darn successful on that. At the end, you can see we reduced our full-time man hours. And the test we did with Joe was twice as complex as the one we did. That's how we got there in about 12 hours worth of work to these series of factors on the specific unit operation that we found. So just using an AI simulator, we estimated we saved just over 700 hours of us investigating and grinding through and trying to find these root causes. But there's some really interesting things within that. We built a data model that was very granular, and that's important. Instead of being superfluous, we got down into very specific things that we could see. And then with, actually, you know what, Joe, I'm skipping ahead. That's okay. With that model, we could better see factors and things that we would want to go after in better descriptive statistics. Instead of what I could come up with in Excel, we were able to see unique numbers and unique relationships that the AI simulator was able to see. Joe, if you could hit forward again, please. Thank you. And then the last part we were able to do was we were able to capture our opportunity, right? So the 720 hours is great, right? That's a chunk of change for one of our engineers. The bigger thing for us was this complaint was a few $100,000 single complaint that we would occur to put batches on hold or to get rid of batches that we couldn't trust. By having this model and this simulator and finding these factors, we saved that problem. But then by having a reliable data model, we got what we call, a little by little, a little becomes a lot kind of mentality. We could use that data model to continue to find little things and little improvements that we could automate out. So our examples then would use automation, our PLCs, our drives, bits, bytes, valves, you name it, to automate out these root causes as a way for us to go forward. A couple of the interesting lessons learned then out of this. One is, hey, Excel is a great way to start. It really is, but it's limited. An AR simulator, in this case, the Action Core simulator that we use, it was more accurate than I was. That's hard for me to put on a slide. I actually deleted that 4 times before I decided to leave it up there. But the simulator was more accurate, and they found problems in our Excel model in like minutes after they loaded it up. That's a little bit humiliating, but that's okay. I got through it. Anyhow, so they were simulating, and using a simulator, that was a great way to step forward. By using a tool like a simulator for a big data model, it is so much easier to manipulate and to iterate around, right? So using Excel as a big data model, you get these 7-minute load times, right? I mean, it's ridiculous. So using the right tool for the right application to enable you to do machine learning and then enable you to do AI, I think is very important. And that was one of the lessons that we learned here. I'm going to jump to the last point, and Joe mentioned this previously about the fear of the black box, and we 100% wholeheartedly had that. We had continued to use this data model to find really cool things that we could automate out, and we specifically looked for things that we could put in our PLC, our SCADA system, our lower control layer, etc. And when we got to a spot where we said, well, maybe we should use an AI engine to predict this, we walked away from those opportunities because we were afraid of losing control. This was our first kind of foray into taking our data and making it information, and we were a little concerned about taking the next step. We said, we'll get to that eventually, and this was one of those kind of positive lessons learned that helped us go on the way. So I'm just going to quick summarize that. By having a simulator and having the ability to build a data model, it does help you get this ridiculous pool of data and actually make information, and you can do something with it. The second use case, we just came off this first one. We were feeling, hot dang, we got this, right? We were going to be so successful. In this second use case, we actually worked with Google directly. They were talking about big data, one of their big database and their big tools. Great set of tools, so this is not a knock on them. And then also in this, we decided that, boy, if a little data yields cool results, let's go in and get a whole bunch more data. So we partnered with Micromotion, a subset of Emerson, to do a whole bunch of data intensification. We found values that we had never used before and grabbed that data and recorded it and threw it into our model to see what we could get. So we had all of this data that we wanted to throw together. So my last one was blue and yellow becoming green. I'm going backwards now. I got green, I'm going to make blue and yellow out of it. It's milk and you're making cream and skim, but the colors are much more interesting. And what happens in this case, and if you know a dairy separator, you every so many period of time, it's called a bowl shoot. You have to clean the bowl, right? Because otherwise solids will build up and your separation will go bad and blah, blah, blah. But because we had all this data and we had all this success, we were going to beat years and years and years of experience of the dairy market. And we were going to find a way to not do that on time, but predict a way to go ahead and predict when we should open the bowls up and shoot and get that loss instead of just following the time, because it would be more money saved. That was our intention. Joe, if you go to the next page. As you can probably guess, we swung and missed in a pretty substantial way for a couple of reasons. Where the first use case, Joe talked about supervised learning and understanding your output and understanding what a cat is. Shoot, we didn't even know what animals were. We were trying to, get really cute and discerning in the second case, completely unsupervised. And we got out of our domain, right, out of our knowledge set. So we had problems building a model that we understood and therefore that we trusted. So we had outputs that could have been inputs. We got to a point where in this learning thing, we had to make a failure, like a failure that would have shook the separator off of its flooring, and thought to ourselves, no, maybe time is good, right? Maybe that isn't the best thing we could do. And then the last little kind of lesson is that we got out of this is that data is in the eye of the beholder, right? So that beauty of the data is in my eyes. That set of work I did with Emerson and Micromotion to make this thing really blinky and lights and kind of cool stuff, I loved it. It was completely useless for us in this context, right? Because it didn't have a context for us in terms of the learning. Joe, if you could go to hit the next, please. So the lessons learned on this one, we call this data isn't free is a key lesson. What I mean by that is you've got to have, look, I can give you all the data in the world, but you've got to do something with it. You got to care for it, you got to curate it, you got to make meaning out of it. And you can do that in supervised learning. The other one is that we had data silos. So we had our ERP data and our quality data, and we had our plant floor data. And individually, they were each very clean, but when you released them out of the silos and expected them to migrate together, it was a mess. That's again because we didn't care or curate for our data and tell it how it worked together. And then humans, right? We needed a champion for this project to look. Somebody higher than my pay grade would have to say, yeah, go ahead, rip that separator off the floor. That's fine, right? You need a champion that's into this. And then you need people to, as you're going through machine learning, the machine doesn't do it all itself. The machine at the end doesn't give you a gift wrapped piece and say, here you go, here's the answer. Because if it did, y'all would already have it, right? We still got to invest our time in it. Joe, if you could go to the next one. So there's 3 buckets of lessons I learned. Let's see how fast I go through this. Oh, quickly. One is this whole thing about data, right? So we talk about data is not free, data in the silos. The last 2, though, are really important. Models are our new standards. If you're an engineering-driven business, if you're a process-driven business, data models are the new standard. It's the way to say this was the golden batch, this was good. That's not. And then models allow us to have competitive advantage, right? They allow us to show us that data for what was good and get better and use it to get very granular and move forward. Next one, Joe. So project definition is my next lesson I would give you. It is okay to have a project that is successful at a 1% increase, right? It may not have this wonderful ROI, but a little by a little becomes a lot. And we use that a lot. So as you're defining projects, I recommend that one. Joe, if you could hit the next slide. So that little square in the bottom is just a piece of us that we use for we define a data-driven project, right? Something that's going into AI or through machine learning. We want our team to recognize where are we in this matrix. Do we know what we're trying to do at the start of the work? Is the objective defined at the start, or are we going to learn it on our way? And then do we have that knowledge today, or are we going to learn that knowledge on the way? Because if you have that knowledge today and you know what you're trying to do at the start, you just execute. You make your AI model, execute, make it predictive and go. A lot of times we're down in this explore area. I don't know what I don't know, and I don't know where I'm going when I start. Understand that you aren't going to get a successful ending. It is completely an exploration exercise. And then the last 2 lessons, Joe, if you go to the next slide. The last 2 lessons are about being a project champion. So good data, good projects, and being a champion. Joe, if you could go one more. This one, my comment to anybody who's a project champion is please champion a result, not a tool, right? The cute little graph in the middle that looks like circle vomit in there, that is all the tools you can use in the AI ecosystem, excuse me. What we talk about is one of 2 things that you want to go after. One, I want to go after using data and creating data models, the big blue circle, as a competitive advantage, right? Or I want to go after transforming our roles. In our use case number 1, we did both things. We did both things very successfully. We left a standard of how a blending operation should work as our data model, and then we transformed the way engineers and our maintenance team and our quality team go at solving a problem. In the second example where we were swung and missed, we had a terrible model, we couldn't get to a good model, and then we also could not get to what role, what human am I trying to help in this case? So as champions, I recognize those 2 things. And one more, Joe. And then our last thing for project champions, if you're a champion in this, especially in manufacturing, we tend to look in that little box, the make box. This is my model of any manufacturing operation. It's pretty simple. I'm an engineer. You can tell I do everything in squares. Anyhow, but we always talk about being in the make floor, right? And make, you talk about things like driving efficiency and driving productivity and driving optimization. My challenge for you as champions is those other three boxes probably offer more opportunity and more advantage for us in combination with that for our AI tools. If you can predict the things that are outside, there's more there. So those are the three big things that we learned in our 2 use cases. Joe, after you.
Thank you, Ryan. I know we're out of time, so I'll be quick with these last few slides. I intentionally put this in the presentation to give the sense of what the reality is. It's overwhelming. There are a lot of vendors, a lot of applications, a lot of solutions in terms of IoT and artificial intelligence and the whole sphere. In fact, this is one slide. This one's even more ridiculous. So I put that out there to make the point that we're aware that it's overwhelming for a company to make a decision about what they should be using or buying. So I like to advise our clients, we work with you to start down the bottom here. What is your company vision and strategy? Usually most organizations, depending on size, have a layer of technology, infrastructure, architecture. What most companies do not have is a data layer. So having a data strategic roadmap with some tactical plans and the components of it. So part of our relationship with our clients is advising them, in addition to the vision and the layer of technology, you need to have a layer of data or data, because that's what drives your business. It's the information, not the systems below it. You make decisions on information. So there should be an information layer, a data layer, in terms of helping you determine which way to go with the landscape that's out there. And with that, we're done. And I realize we're out of time. I apologize, but thank you for letting us present.
Thanks, gentlemen. Any questions for these guys?
What is a data model, and what are the red flags of a bad data model, and what are the tenets of a good data model?
So, Joe, I don't know if you heard that about what's a data model, what's good and bad. So I'll swing, and then you can be second at bat here. So for us, a data model for us represented a function, a unit operation that we could see inputs and outputs, and I could map. You want to get really geeky? ISA has a thing called the S88 plant model. I would build it around that, and I could map a unit operation to that. It is something that, as our engineers, we could look at and say, this is how something is supposed to function. And sort of clear inputs and sort of clear outputs, right? I don't want to say clear inputs and clear outputs, because that's just a little bit aspirational. A bad data model is a bunch of data around our separator that we could not correlate descriptive statistics to say that's a cause and effect, that this blinky light was because that happened. I couldn't tell if the blinky light made that happen or that made the blinky light happen. That was a bad data model for us. Is that a fair? Joe, you want to add clarity or add your commentary?
Sure. Just in terms of the language of data model, compare that to the language we use for financial model. What's your business model? What's your finance model? So it's just really defining the approach. What's your approach for your business or your finance, and what's the approach for the data? So we start with identifying the objective. So the objective drives the data and the approach to achieving outcomes. So again, with language, it's just about approach and methodology.
But one more piece of color to that, and then somebody make me stop talking, right? So we just need to, we have this thing, there's an official name to this, but we affectionately call it the Donald Rumsfeld square. There are known knowns, and then there are unknown knowns, and there's the other four, right? If you're in the land of unknown unknowns, you don't have a data model. And at least that's what we look at. If I could not correlate my inputs and outputs to inputs and outputs, that's Brian, the process engineer, the chemical engineer, talking about our unit operations to translate that back to Joe. Anybody else? Awesome. Thanks, everybody. Thanks for the opportunity.
All right, so we're on a break. We've got some refreshments upstairs if you need something to drink, a little snack. We'll be back down here in about 20, 25 minutes, something like that. 2 more presentations, one on IoT and one on press room automation. All right, here we go with conversation on IoT. So I hope you've had some good discussions, though, during our breaks and with our other speakers and our peers and your peers. It's now my pleasure to introduce Tony Kaczmarek. Tony's presented at this conference before. Today he's here to give us a little history lesson on what we've learned from IoT implementations over the last several years as IoT has moved from isolated systems to fully integrated and quick-to-value solutions, solving real-world plant production problems. So Tony is Vice President of Product Manager at Plex, where he focuses on Plex manufacturing automation. Prior to joining the Plex team, he was President of Coors Engineering. Please welcome Tony Kaczmarek.
Testing. Everybody hear me? Awesome. Okay, so you sandbagged a little bit. Several years, so we've actually been doing IoT integration long before IoT was any sort of catchphrase. Getting some war stories with some of my peers out there about starting into PCs and PLCs and huge hard drives and using PC Anywhere to connect, for those that are of the age, PC Anywhere connecting through a modem or through ISDN to try to see these remote sites. So I've been doing this stuff for a long time, so I want to talk about some of the stories about what we've learned through all those years. As I mentioned, I'm now with Plex. I ran Coors Engineering for quite a few years. Our specialty was facility and industrial automation. And then around 2001, we started getting into manufacturing integration, doing integration into the cloud. So we've gone through quite a few iterations through those generations. And about 2 years ago, Plex liked our product well enough that they acquired us. And about a year after that, we got acquired by Rockwell Automation. So I went from 15 people to about 700 people to around 28,000 people. So a little bit of adjustment on my part. Our company came up with a product called Mach 2. So if you hear me kind of slip into that terminology, Mach 2 was a platform, a SCADA solution that we created to make integration from the shop floor into the cloud, into ERP, into MES, very easy, very quick, very rapid. That product has evolved a little bit since we've been acquired. That's basically still the platform, but we've got a couple of products that have evolved out of that, one called automation and orchestration, which is basically tying into the MES system and doing all those transactions of recording production, recording scrap, getting your OEE, doing line-side labeling, traceability validation, all those types of things. Production monitoring is kind of, think of a standalone entry model that gets you into some of the key metrics and OEE performance metrics on your plant floor. So some of the things that we've learned through the years, and it was kind of a fun exercise. I always try to do something new, something fresh, and make sure that Brad doesn't kick me out. I want to keep this new and relevant. So I kind of took a look at about a dozen of our customers that we've had for 15 years or more, and kind of took a look at some of the things that I noticed that made them so successful through the years. That's one of the things that I've really enjoyed is when I first started my career, I would see these boxed packages of software. That's how they used to deliver software, and discs and CDs in a big shrink-wrapped box. But I would see on the bookshelf all of these shrink-wrapped boxes that had never been opened. Thousands and thousands of dollars of money spent on this software that was never even opened. One of the things I take a lot of pride in is walking into all of our customers that we've had for 5, 10, 15, 20 years and seeing our software still up, still running, still being innovated, still being used every single day, watching the managers, the supervisors, the operators using this every day, and then watching the innovation. So taking a look back on that, I want to take a look at some of the things that really made them so successful through these years. So one of obviously the first thing is connectivity. How do we get down into that plant floor? How do we talk to things? And that may seem pretty simple, but talking to some of my peers out here at Polaris, it's amazing how many plants that I walk into and there's literally not a single work center that's integrated at all. There's no Ethernet connectivity. there's no visualizations. It's just making parts. And I see definitely in metal forming, I see that frequently. In fact, I was just out at a plant last week in the west side of Michigan, and they must have had 30, 40 work centers, and not a single one of those had Ethernet connectivity. I think there's a little bit of an overwhelming thought that this is going to be a huge investment. We're going to need to buy, $15,000 PLCs and hire some very highly skilled people to go in and program everything and network and infrastructure. But what's really cool is we're now in this new IoT age, and that's really kind of been a game changer and really enabled us in a lot of different ways. So the first thing is getting that connectivity, and what's made us successful with our customers is making sure that we're able to tap into all of those disparate systems. I heard somebody bring that up earlier, that I've been at one company where we had all Siemens, all Allen Bradley. Those are pipe dreams, and every time I walk in or stumble into one of those, it's super exciting because that's such a slam dunk and a home run. The reality is most of our customers have different models, different generations, different controllers. Sometimes it's not even a controller. Sometimes it's a proprietary system that stores data into a database or into a flat file or a CSV. So we're always looking at, what are the opportunities for us to tap into those systems. I heard Mike talking about tapping into their CMM system. And that might not always seem like an integration point, but to your point, you look at all of the time that is spent on a CMM of entering data into another solution. That's huge. If you've got 50, 100, 400 points of data that you're collecting and you need to get that information, again, using open architecture tools for us to be able to get that into a quality check sheet is just continuously one of those next iterative things that we can tap into our system and pull it into the MES. Now what we're seeing is things that used to be kind of prohibitively complex or expensive for us to tap into are now starting to open up. I heard somebody talk about the proprietary nature of things, and that's really, it's just not efficient or effective. But now we're starting to see, obviously, OPC, DA, UA are some protocols that are really opening up some things. But even on some things that historically have been very proprietary and very closed, we used to see injection molding and CMM machines and the other solutions, just getting into really, you have to buy our solution. That's the only way. Buy our package. But we're starting to see that really evolve. Everybody's starting to recognize that there's a higher power that they need to report to. That's got to go into an MES system. So we're starting to see things really open up a lot. Obviously, as we talk about AI, and we start seeing the opportunities as we get into the next generation of opportunities of getting into machine language and AI, getting into vision systems and augmented and virtual reality. All of these things that we want to make sure that we never have a closed door to those. We always want to make sure that we have an open architecture way to talk to those. AWS, Azure, Google, all of these things are more opportunities for us to use their tools. It was funny because when I was working at Coors Engineering, I was always terrified to get into heavy-duty reporting and analytics and stuff. And I said, sure enough, I'm going to hire 6 PhDs. They're going to be the smartest in the country. I'm going to put them in a room, and they're going to create the best solution. And the next day, Google's going to say, look at what we've got, and it's free. Sure enough, we're already starting to see that. We're starting to see in Azure and AWS and Google, all of them are starting to offer analytics and tools that there was no way we were going to be able to compete. So making sure that we have the APIs, the communications, the paths to be able to talk to those right now or in the future. Again, we see a lot of our customers, they're not there yet. And there's that fear of missing out. There's all of the marketing. There's all of the emails that they're getting that you have to have AI, you have to have machine learning, you have to have digital twins. And those things are all amazing. I mean, we got to see and hear some of the stories of really cool things that you can do with those. But the reality is when I walk into a lot of these plants, they've got a work center that's stroking, it's making parts, it's leaking oil on the floor. And talking about getting into a predictive maintenance perspective is really cool.
But there is a much more fundamental layer that we can get them to very rapidly, very cost effectively, without a lot of disruption. IoT devices, technology has really changed things as well. Seems like about every month I'm seeing a new device, a new technology, a new screen, a new tablet or TV, and all of these things are really continuing to enable us to collect data, but also to present it. It used to be for us to present information in 1997, you'd have to have an HMI in the plant floor. Those HMIs cost, what, probably $2,000, $3,000, $4,000 for us to put one in place, required special programming, and if you wanted to have it at a second one, you'd have to spend another $3,000 or $4,000 and have some specialists come in there. Now, our solutions are browser-based and deployed, so you can wait until Black Friday and go to Walmart and buy 12 TVs for $200 a piece and throw them up all over your plant. Almost every one of our customers, we're seeing that happen. This fear of saying, well, if I put a TV on the plant floor, it's going to be dead in 2 years. Don't care. They're $200. They're practically disposable now. So all of these devices, all of these input IoT devices, Advantech, Banner, Allen Bradley's got a few, Modicon's got a few. These are sub $200 devices. And really what's cool is, we talk about context. Pairing just a very, very simple signal from the plant floor, iCycled, paired up with your MES system, and Mike, you were talking about making sure that there's one point of entry, one truth. You hear that a lot, especially in our ecosystem. Making sure that you don't have these islands of information. But if we've got that one simple signal of iCycled paired with job information, part information, container sizes, rates, guess what? The only thing that I need is that signal that I cycled, and I can give you OEE, I can give you uptime, downtime, microstops, I can do line-side labeling for you, I can do record production for you. So there's a lot of things that I can do just with that very simple $200 device that I can collect 8 machines' pieces of information into an MES system, and that can be done in no time flat. So some of these obstacles that we used to have with very costly, very complex, very specialized, where we would need a PLC programmer to come in. Now you can go to Advantech, spend $200. That's changed a little bit because of supply chain and the availability. But you get a little puck like this that you can have your electrician hook up, no programming, just configuration, and get that cycle information. And suddenly, this very opaque plant floor that you can't see anything, now all of a sudden you're seeing real-time information every single cycle. Every single second, you're getting updates of exactly how you're performing. So some really powerful stuff. And again, there's more ways to deliver this than ever, and more cost effectively. Again, I used to look at some of the devices that to get information on the plant floor, especially industrialized tools, thousands and thousands and thousands of dollars. I've seen one of our customers went out and found $40 Google tablets, and were able to display all of the information that they needed on their fork trucks. They 3D printed a little mount for these tablets, and they put one on every work center. So this really starts to blow things open. And then you take what we have with the internet and the ability to text message, to email based on certain conditions, and communicate to people anywhere in the world and have them log in and see what their performance is, look at what their production is. This stuff is so powerful, and it's all just waiting there. This isn't something where you have to build an entire huge infrastructure. A lot of the stuff is in place. So a lot of what we've focused on is solving real problems. And this isn't, hearing some of some of the more advanced things of AI and additive manufacturing. Those things are really cool, and I was really excited to see how far they've come to be, really practical solutions. That's one of the things that we've always found with manufacturers, is they are very practical and very conservative with their money. So you've really got to prove that what you've got is going to solve problems quickly and cost effectively and get you a good return on your investment. So we would sit there and take a look at every instance where we'd sit down with a customer and take a look back at what are the things that we ended up solving every single time. We used to go in with a very broad whiteboard approach and say, what do you want to do? We're systems integrators. We have a SCADA system. We can design and create anything. Engineers love that. It's hard to make money like that. But when we took back and pulled back a little bit to take a look at what are the things that we are seeing consistently and what can we deliver to, to reduce that time to return, but also provide a platform that you can solve, any future problems, any future technologies that you might want to address as it comes down the line. Manufacturing is always evolving. Your customers are always evolving. So you're always kind of adjusting to what you need to deliver. So we wanted a little bit of best of both worlds. So we wanted our cake and we wanted to eat it too. Again, when we look at, I listen to comedians every day. There was a guy that was talking about these motivational speakers about the guy that climbed Mount Everest, and he's coming out there to motivate you. And sometimes you got to realize that he's like, what's your big obstacle? And he's like, you got to realize that his obstacle was Mount Everest. What we don't want to do is we don't want to create a Mount Everest for you. We don't want to create super complex systems that take a year or 2 years to deploy. That takes a large team. That takes a lot of documentation and planning and strategy and investment and buy-in from every level. So we wanted to come up with some very practical solutions and very practical return on those. So all of these things are really cool. Lights out manufacturing. That's amazing. We should all be there tomorrow, right? Let's do it. Let's flip that switch off and we're ready to go. Well, everybody here knows that's really tough to get there. There's a lot of investment. There's Herculean efforts to get there. There's so many challenges, so many pitfalls, but there is a path to that. You don't necessarily need to take that huge leap. There's a much more iterative approach to get there. So again, these Mount Everest are really cool, but there's a lot of liability that comes with those. So again, what we did is kind of took a look at what are the stair steps that really help our customers get to success very quickly. We have really proven this out, and that was one of the reasons that we were acquired, is we were so successful at doing this. Again, we had a company of 15 people. We had about 4 or 5 people doing solutions worldwide at around 200 plants. So it's a huge testament to the amount of impact that we had on customers as small as 50 million and as large as probably 50 billion, somewhere in that range. So we knew that we had some really solid ideas of really how to deploy this successfully. And again, pull that back, create a package solution to address the things that we could solve with very simple information. I heard the conversation around those different PLCs, those different generations, and that can provide a lot of challenges. It's very interesting to walk into a facility that, let's say they're making washers. The first work center is maybe from 1940, and it just cycles. It's relay-based, and it does as good a job as anybody, and it creates those washers. They go out on time, never any issues with it. Literally 3 feet away, you got a 2022 machine, and it has the most advanced Siemens or Omron or Allen Bradley PLC. It can give you 2,200 different downtime faults. It can give you vibrations and all of those things. So what we learned is we needed basically an environment that we could handle both of those very effectively. Basically normalize not just the protocols, but the behavior. So we were basically creating a workspace that could either use just a simple ice cycled all the way up into a very sophisticated system that could tell us about rejects, about downtime, about quality information, about traceability and serialization. So we wanted to have an environment that could handle all of those. Excuse me. So the result of that was our team pulled back, and we spent about 2 or 3 years. I really didn't honestly think it was possible, but I had some very sharp engineers and some good leadership, and I listened to them, fortunately. And they went off into their hole, and as engineers do, shut off their lights and glow of their monitors, and they created a solution. And it was really powerful because it did address the diversity of equipment that we had to face. It basically normalized and made it very quick for us to do a full MES ERP integration. It made it very quick for us to integrate into quality systems. So out of the box, we literally created a solution that within a day or two, we were able to get a company from nothing into recording production, line side labeling, uptime, downtime, OEE, performance, digital whiteboards. You know, just always would crush me when I would walk into a plant and I would see an old school whiteboard and people filling in that information. When we could have a whiteboard that updates every single second and shows you exactly where your quality is, where your production is, can give you details about why it was down during that time. Then again, we wanted to make sure that we could address and provide a path of success for our customers. So literally our first customer from 2001, when we put that into production, is still running 100% today. Thousands and thousands and thousands and tens of thousands of transactions every day going into their MES system, capturing uptime, downtime, record production events, line side labeling, generating labels. So we wanted to make sure that we didn't shortchange our customers and provided a path to allow them to get into those next things that they wanted to do. Because we knew every time that we sat down with a customer, everybody, performance, that's kind of the sexy thing to sell, right? The little donuts and the bar charts and the graphs and the colors of the red, yellow, green. Everybody likes to see that. And it's an easy sell to management. But we were working with the production supervisors. We were working with the operators. We were working with the people that were really impacted and slowed down on the plant floor. So we wanted to provide a solution. And we heard every single time, yeah, OEE and all that stuff is really cool. I'd love to see that. But here's really what my problem is. I'm not packing out right. I have miscounts. I have bad labels. I heard somebody talking about pre-printing a bunch of labels, and instead they want to earn a label. We want to do validation as it moves through each work center to make sure that it passed the previous one. We want to get traceability. We want to get quality. So we heard that message every single time, yeah, but. So we wanted to focus on the but. That sounds really bad. And focus on what else that we could do and make sure that we always provided a path for our customers to be successful. So again, as we introduced our product, we were able to kind of carve out a little bit of a production monitoring environment alone and provide kind of an easy entry point for our customers. Yeah, I'd love to get there, but I need to start here. I just need to get some visibility. I need to see how well I'm performing. And maybe once I've got that, then I can start justifying that to go into, here's the reasons why we're down, or here's, we're showing that we're doing all this production, but we're not capturing it. It'd be great if we could actually do that automatically. So we have an offering that starts at that production monitoring, and then going up into each of those different tiers to be able to do more and more things and enable our customers. And that isn't something that they have to eat all at once. That's something that they can do very iteratively as they have time and resources. And then again, addressing that technology stack. And this has been, as a geek, it's been a lot of fun for me to watch as we've seen our customers. And really, one of the things that's really cool is we're somewhere in the probably 7,500 to 9,000 work centers that are integrated into the ERP MES solution. And the reason that I don't know that, what the exact number is because our customers do 90% of our integration, or 90% of their integration. So what we do is we basically teach them to fish. So what's been fun is watching how our customers have really leveraged these tools to integrate things like their HVAC system, integrate their task lighting, integrate you had talked about tracking your supply and your containers being full. One of our customers created a tablet solution that showed how many minutes until they expected that container to be filled or when that supply source material will be running out. We've had customers integrate cameras
and vision systems, augmented reality, AGV systems. So as each of these new technologies come out, just another opportunity for us to take advantage of that and integrate that into that single system of truth and actually do something with it. So most of our customers go through this path, this journey. We'll typically identify a pilot. We'll find out, what do you need to do? Let's start simple. Let's just get that uptime, downtime. Let's just record production. Let's just get a few of these things. We'll teach you how to get the tools. We'll train you how to do that, and then we'll teach you how to scale, and then we'll start working alongside you or letting you really kind of take the reins. It's amazing. Every once in a while, we'll see like an intern or an OT person or the guy that fixes the labels all of a sudden jump in and start taking these tools and taking them to the next level. So one of the things that we, as all of this stuff was happening, anybody that knows a SCADA system knows that a SCADA system can do anything. Just like programming in C, C++, Ignition, you have a platform that you can do anything. And one of our challenges prior to the acquisition and even to a degree post-acquisition is explaining all of the goodness of things that we can do. So one of the things that we've been trying to do is categorically start breaking it down by broad categories and then getting into subcategories and getting into use cases about how each of our customers are using these types of things. So that's one of the things that we're evolving. And again, making sure that they start the journey and are assured that as they go through their journey, that each next step, they have an option of, oh yeah, let's take a look. I want to integrate this work center. I want to do this functionality. What tools do I have to work with? Do I have a weigh scale? Do I have a barcode scanner? Do I have a vision system? Do I have an AGV? Do I have just an operator? Is it just a table where a guy pushes a button to indicate that it's done? So we take a look at what those tools are and figure out how to let them leverage those tools, make them effective, join it with their system of record, and make it as useful as possible. So the thing that I love to see is those customers that we've had for decades, and literally, talking to them every week, every month, and finding out the next thing that they're working on. I'm like, oh, you're kidding me. I never even thought about using it that way. Or sharing, things that we're doing and say, hey, we've got a new platform that allows you to do screens without any sort of, expertise. And that's one of the things that we really focused on. We realize that most manufacturers don't have a bunch of geeks sitting on a bench that are just waiting to code. There's not a bunch of people that know how to use SCADA systems or know how to use PLCs. So one of the things that we really spent a lot of time focusing on is coming up with a platform and an environment that basically opened up and created a citizen developer environment where we could take any resource. And we've literally seen that. We've seen 18-year-old interns come in and integrate an entire stamping facility of some 60 or 80 work centers. I've seen directors of IT say, I just lost my guy, I guess I'll do it. I've seen quality people, I've seen OT people, I've seen PLC programmers. So what we wanted was a code-free environment to really democratize who's able to go in and support that system, especially now that we're seeing all of this churn and this loss of expertise. Being able to kind of get to the next guy to be able to support that system was really critical for us. So we've basically come up with a very, it's all about systems, which is unfortunate because I'm not a systems guy. I'm the dagger guy that pokes the polar bear, unfortunately. But as we've matured through the years, we found a very successful process that is very successful, very scalable, and really sees our customers see the maximum success and the maximum return. So we talk about, and it's cool because we're talking about this thread of conversations between these different speakers today, and you'll see in and out weaving some of these discussions. So we talk about the pilot, basically getting that success story, engaging with the people that are going to be using it, engaging it with the people that need to solve those problems, and then make sure that it's accurate, make sure that it's reliable. One of the worst things that you can do is put out a system that maybe is alarming 200 times an hour, so everybody ignores it. Or you see a system that has a wrong pressure or a wrong temperature. All of those things create distrust. If an operator, we talk about OEE in this kind of ambiguous number that really doesn't relate oftentimes to an operator. So one of the things that we try to do with our screens is we'll get very tangible information. We'll show you, obviously your target versus actual and your production rates and those types of things, but we'll also show you that pieces that weren't produced because of downtime, pieces that weren't produced because of quality issues. So we like to get some of those tangible things and engage with those operators and make sure as we go through and deploy that pilot, making sure that that's successful before you scale it. Listening to Mike go through his iterations, that's very common for us to say, okay, let's try it. And it's really interesting that as you go through these exercises, you build that excitement with the supervisors, with the operators, as they start to see that real-time data and start to see the impact of it and start to say, that's wrong, and engage in that whole conversation. This customer that I was visiting last week, they've had our product for a while in another plant, and they said about 90% of their operators have very positive feedback about having these types of solutions in place. I used to worry that it was going to be very kind of Big Brother-like, but what we found is people really appreciate it, and it really starts up those conversations and sparks up that engagement between operators and supervisors. So again, making sure that pilot is up and running, and then sharing that. Anybody have their stocks on their phone that they track? Probably a few people here. It's addictive to watch that. Not right now, it's pretty horrible. But historically, it's kind of fun to watch your ticker and see how much that you made for that day. In the same way, real-time information is very addictive. So what we found is when you put even that single screen out there that has real-time information, every time that you hear that press stroke, you see the count go up. You see it turn green or red. That's very addictive. And then suddenly that next person walks by and say, oh man, I could use that. So what we found is once you get that on the plant floor, once you share that login, it's super addictive. You log in and you say, ooh, how are we doing today? And it's kind of like a excitement as opposed to, boy, I don't want to walk on that plant floor and hear what went wrong. Instead, I can log in and see what's happening right this second and be able to really reduce those decision cycles. And then we've been focusing a lot on this continuous improvement and best practices. So setting up this really iterative approach, we talk about the everyone to everyone. So making sure that everyone has a voice, an operator can log in and basically type in a message that will go back into an employee suggestion program and say, I bet you if we did this, we would be able to, save 20%. So making sure that you have a process in place, and then that you're reactive and that you're tuning that and improving that. And then once you've basically got that in place, watching our most successful customers have very rigorous structure and templates and programs to say, okay, we're going to do these work centers. We're going to put them connectivity. We're going to get it talking. We're going to get data to the screen. We're going to set it up in the MES system, and we're going to flip a switch. And we're going to do these 5 work centers this week. Very process-oriented. And those customers that go through those exercises are very successful. And then they just scale and repeat. It's fun because every once in a while, I'll talk to our services group. We just did an implementation in Europe, and I hadn't heard anything in about a week or two since they had brought the pilot online and had kind of tuned it. I said, it's quiet, a little too quiet. That's usually not a good sign. How are things going? He's like, they've integrated 84 work centers, and they've done it on their own. Whew. That's what I love to hear. What I hate to hear is we did 2 work centers as a pilot. We did that 6 years ago, and that's all they've done. To them, it's still worth it. It's keeping Honda off of their back. It's getting accurate information. It's recording production, getting labels. It's doing good enough, but I just keep nudging them. I'm like, exploit us. Use us.
And then watching our customers basically build that into the everyday strategy. And I heard a couple of conversations around that thread of, as you're talking about setting up specifications for your for your suppliers, we know that not everybody typically is going to be able to provide everything for everybody. So working with your suppliers to say, hey, I need to make sure it's open architecture, I need to make sure it's Ethernet capable, and I need this data block. I need, what's our production, what's our uptime, downtime, do we have faults? And especially as I watch some of our customers bring in things from overseas, and they're installed by somebody from Denmark, and then they leave without giving them a password or access or documentation. So it's really critical as you're starting to scale, as you're starting to make this part of your strategy, to make sure that you're holding your suppliers accountable, to make sure that they're making sure that it's open architecture and accessible. And then building kind of that dream team. Not necessarily getting everybody to be an expert with our tool sets, but making sure that they know what the impact is, what they can do with it, what the end results will be. Because what we see is suddenly the quality manager that's never touched the tool, but kind of sat in on a training session and watched some of the things, said, hey, can you collect 32 data points from that PLC and put that into a check sheet automatically, validate that, give me the green flag, and then send a message if it's not? Yeah, absolutely. So it's really fun to watch our customers suddenly start to think out of that box a little bit. Talking or listening to the additive printer guys, hearing about how customers are looking at it, oh, it's just a tool. It's not just this one thing, it's just not this one solution, it's a tool. And once you pull back and you think about it as a tool, whether you think about Excel is done for one thing. How many people use and abuse Excel horribly to do AI? But watching, once our customers kind of see what they can do with that tool platform and really exploit it, that's when it gets really fun. So watching that dream team as they're going through their next product launch and thinking about, hey, I'd love to do a vision system, I'd like to capture this and that, and just setting all of those expectations and making that part of the strategy, part of the specification, part of the requirement. So when that machine comes in, you're ready to go. And again, using operators has been really integral for us to see that success story, because they're the ones that have to live with it all day, every day. So we'd spend a lot of time with operators and say, does this look good? Does this feel okay? What would you need to do this? As you create those custom screens, as you create that workflow, make sure that they're engaged in that. You'll get a lot better buy-in and a lot better success in deployment. So I got to hustle a little bit here. So I was hoping to have Luke here, and he had to bail late. But Luke Abrams is one of our users. We've been working with them for about 12 or 13 years. And when we were approached by them, they had already had the MES solution in place, and they said, we'd like to start simple. We'd just like to get some visualization, uptime, downtime, production information. We said, okay, here you go. And they kind of went off, and they were very happy, and they scaled that. They went to 20, 30, 40 work centers. But they didn't stop there. Every time I talked to them, they would go through a new iteration of improvements. They had sleeves, special sleeves that they would put on an exhaust tube to protect it. And that sleeve could only be used 4 different times. It had a serial number on it. They said, could you guys find a solution where we could track how many times that would be used and then reject it? I said, okay, not a problem. Hey, we have Honda issues. We'd really love to handle small lots. Hey, we have another issue where we'd like to do an augmented reality. We'd like to have a projector showing us where to put the parts. Okay, check, keep using it, keep expanding, keep exploiting, keep abusing our system. Oops, let me go back. So one of the latest things, I said, hey, look, what are you guys doing right now? And it was really cool to hear some of the things that they've done, because we talk about this graduation from full operators, full engagement into this dream world of lights out. And they had a work cell that was an exhaust assembly line, and I think they had 6 to 8 people working on this line. And they kept going through generation
upon generation and kind of iteration upon iteration. Very non-disruptive, very, hey, I've got some time to work on this week or this month. Hey, I've got a couple bucks to buy a new controller, a new vision system. So they just kept incrementally improving that system and putting in a vision system, tracking quality, tracking welds, checking for leaks, and then being able to point out where those are to help save operators time. So they went from basically 6 or 8 full-time operators on that line to 1 to 2 people that kind of weave in and out of that operation. So they continue to kind of exploit the system and keep finding new iterations literally every month that I talk to them. And what's cool is, I was talking to him, I said, are you guys working on this full time? He's like, no, our responsibilities are IT. All of this type of work, we've got maybe 10 to 15% of our time is allocated to these types of projects. So these aren't things that take hundreds of thousands of dollars or months and months and months of effort. These are things that you can really kind of belt out. So these are just a couple of the samples that they've been doing. So what they've done is they have kind of continued to train a couple of their team to learn how to use the tools and how to deploy them. They're able to support, I think they have 3 or 4 plants that they're supporting remotely. And they are just continuously looking at, how do we improve? How do we take that next step? For some reason, oh, here we go. Let's see if this plays. Come on. Oh, it's not going to do it. I think I just shut down your computer, Brad. Oh, here we go. So in this case, what they had is they have a door sash. And they had problems with orientation, color, and the right part number. Sorry, I'm crushing your computer here, Brad. So what they created was basically a vision system that as they're sliding the piece into each of the slots, they have a vision system that's watching each and every piece, making sure it's the right orientation, the right color, and the right part number. And then you'll see it as it goes through, it'll continue filling each of those slots. These are not in sync because the computer's a little dog. But it'll give the operator an interface to show that each of those was correct, each of those slots was filled, and when they see a count of 30, it'll automatically print out an earned label, and then they can continue and pull that rack out and start the next job. So this was, again, something that Honda was just crushing them. They weren't shipping the right parts. They had miscounts. They had the wrong parts, the wrong everything. And this was a solution that they put in place that just solved all of those issues. That's what I got. Questions? Awesome. Thank you for your time. Oh, you have
we got one in the back here? Yep.
Video games like Halo 2, if you're a gamer, released in 2002, Bungie finally shut down the servers. Now nobody can play online.
Yeah.
That being the example, what are your thoughts on the longevity of these technologies?
Yeah, so that is one thing that we have continually focused, especially since we do have a productized version that we need to be able to upgrade. And that's the challenge when you give a customer free rein to code and create and do whatever they want. There's danger in that. But what we've done is continuously create safe spaces for us to be able to provide an upgrade path to take their logic to preserve those screens, that logic. So again, we do have customers that we've had for 22 years, and we've seen them go through Server 2008 and Server 2012 and whatever. Sorry, I'm not an IT guy anymore, but all of those different versions, these are made up of Kepware and a SCADA platform, and we've gone through each of those different generations, minor and major. And it's not always anybody that's used a SCADA system
You don't always just say upgrade and everything works perfectly. So we do have a system and path with our team that works with our customers, and there's usually a small engagement to just say, hey, we're going to pull this in, we're going to do some testing, make sure all the objects work from the last one. So we've had great success in that generational. And as we integrate into the MES and ERP, those are all cloud-based. So that code is changing every day. So we're very used to that. Thank you. That was a big file.
Well, so how do we get? You don't need PowerPoint, do you? I don't know how to get the mouse back on this stupid screen. Figures this would happen now, right? See, look at this. Come here. I can't get the mouse back on the laptop. It's on this thing. See it there? Yeah, it needs to be on the laptop, not on that. I don't know how to get it. Oh, there it is. I got it. Sorry, guys. Yay. All right. So let's talk now about press room automation, which, again, like I said earlier, in my opinion, automation is a big part of Industry 4.0. It solves a lot of issues on the floor. What to automate, when to automate, robots versus other types of automation equipment. So our presenter on this topic is James Schweiderman. James is a specialist in press room automation at Machine Concepts. And again, he's going to discuss how, when, and what to automate, where robots and other automation solutions best fit. James started his career designing dies and weld fixtures, as well as automation cells. Then he moved on to project management and applications, and now at Machine Concepts, he leads sales efforts for customers in the appliance and automotive industries. His experience in designing tooling and turnkey systems has helped him provide customized solutions for customers, automating existing as well as new press room applications. So please welcome James.
You guys hear me all right?
All right. You got the slide changer?
Yep, should be good. So yeah, like you mentioned, started off as an engineer and project manager, and got promoted to sales. So, what was that? I thought I turned it on. Can you hear it better now? No? Same thing? Oh, now. Now? All right. So, we'll go through these slides and see how we do. So, Machine Concepts in general, we've been in business for about 27 years. We've seen a wide variety of applications, whether it be appliance, automotive. We do a lot of press automation, front and back end, along with a lot of other automation and custom equipment projects. So how we kind of look at it, really as a company, you know, we're providing solutions for the system. You know, our engineering capabilities is really what we're selling. If you can buy something off the shelf, typically, you know, you're better off buying it off the shelf. What we like to see is kind of a part from point A, and we bring it to part to the final product, and with our recommendations on how to get it there. You can see we do the turnkey systems, custom equipment design and build, and we also build the print a little bit. And as we get in here, we'll start talking about some instances of when and when not to automate from what we've seen in the past. So some of the when to automates, and I'm sure there's a lot of people here that have a lot of other bullet points that you can add to this. Typically, the high volume, 3 shifts. If you have a lot of manual part handling, if you're doing any manual packaging with boxes, you know, there's box erecting, box tapers, robotic box erectors at this point. Ergonomic and safety issues. You have a lot of operators involved. So, you know, kind of the picture down here is just an instance that we took from one of our projects that we were looking at automating. Now, some of these guys are just kind of guys hanging out, like these 3 guys back here. They're typically not involved in the process. But, you know, when we walk by a press and we see all this packaging, all this manual labor going on, that's a good signal that we should at least be looking at automating that. And then, you know, obviously everybody has their own ways of conducting their ROI studies. We try to help our customers out with some of those numbers. But, you know, everybody has their own way of figuring that out. Kind of getting here, so a few of the bullet points, just going over kind of the ergonomics and safety. I'm not going to play this video, but it's kind of the old one that I think everybody's seen with people doing the hand transferring in the press, right? So that's the safety issue, right? So if you have any sharp parts that your operators are handling, heavy parts that they're operating or moving when they're line of fire, you know, bending and twisting to load dunnage, part weight prohibitive. Then, you know, also on the front side of the line, you know, when you're cutting bands from your coils that are loaded onto your decoiler, you know, are there ways to automate that? You know, typically you have a hold down arm, but we've also seen some applications where it makes sense to robotically cut the bands rather than manual cutting of the bands. And then also when you load your coils, you know, instead of doing it with a forklift loading a mandrel or a crane loading a mandrel, you know, having a coil car in there, something like that, to keep the operator away. And then, you know, obviously the area scanners and all the automation that goes along with that to keep the operators out of the line of fire. A few items on calculating the ROI payback, which I'm sure there's a lot of people that are very familiar with this, and there's many, many more items that go into this decision. But typically, you know, the number of shifts, right? Operators that can be relocated. It's typically not removing operators, it's moving them to where they can be better utilized. Operating costs, you know, if you have a very large vacuum system, you know, you got to account for that type of thing, how much air is going to be generated, capital costs of the automation, spare parts, and then the costs when the operators are not available. The automation should typically be able to turn on every Monday morning, regardless of what happened on the weekend. You know, the spare parts for automation, you know, that's becoming more and more important with the supply chain issues. You know, you got to have more items in stock now just because of the lead times of getting those parts back in. Some of the challenges, you know, to automating presses specifically. So, you know, we've automated a lot of different projects with robots, but that high strokes per minute on some of the press applications that we see makes that very tricky. Parts coming out of the dies inconsistently, you know, if they're falling out every which direction. That's a little prohibitive. What you'd like to see is, you know, parts falling out in a nice orientation to where you can get some type of a mandrel or mechanical way of automating that type of application. You know, one of the big challenges we see in a lot of press rooms, you know, you might have one press, but, you know, it may be running 12 or 15 different parts. So trying to come up with a solution that can either handle all the parts or be able to get out of the way when you're running the other parts, and when you bring it back in, that you don't have hours and hours of setup time to make these part changeovers. keeping in mind, die maintenance. You can't stick a robot and a servo unloader right in front of both ends of the press, and then they have no way to get these dies in and out of the machine. So those are the items that are kept in mind. Sometimes we run into issues with vision systems using cameras if we see a lot of vibrations around the presses, or if you have aluminum. The lighting's getting better on a lot of these camera systems, but historically that's been a challenge. And then, I heard somebody bring up the floor space availability. Not everybody has the room to put roller conveyors, everywhere to shift totes in and out of the way. I really liked that idea of using kind of just bigger boxes. I mean, that's a great solution. And then a few other challenges, multiple out dies. If you have parts coming out the end and then parts coming out this way, one robot's not going to be able to reach both of those parts. So the price to that can become, prohibitive. And then integrating the safety into the automation around the press. Presses have a lot of safety requirements in themselves. When you start adding the automation around it, especially on existing press lines, we have to keep in mind how the end product's going to look so that the operators stay safe. And there's many other items, I'm sure you guys are thinking of other items that you ran into trying to automate processes that are not listed here. It's a very case-by-case type situation. So handling high strokes per minute. So you can kind of see there the far picture on the left. That's kind of a nice situation. So if you have a high strokes per minute, but you can still get the parts that kind of fall out of your chutes in some type of an oriented fashion, you can pick 10 parts up at a time and put it in the box instead of trying to grab every single part at a time. To where this other picture, these brackets are just all over the place, falling out of the press at a very high rate of speed. Trying to get some type of robotic system to pick it up as 200 strokes per minute, 2 parts coming out, is just probably not feasible. And what we've been doing potentially is trying to just get them to fall into boxes, and if you have to sort them out later, do a secondary operation on that. So like I say, use some escapements to allow the parts to build up. We've had some success using magnetic conveyors in certain applications. And then dial tables with some mandrels, which another video coming up here will show an example of doing that with some motor laminations. Maybe. Well, that's why. Hold on. It doesn't like videos, like he's saying. Let's see what happens here. But essentially, there's some videos of parts coming out of the presses very quickly, falling over mandrels. Speaking to it, it's not really going to do it justice, but essentially that's kind of what's going on. Let's see if it picks up here. Do you want me to just skip through these for now, or I can? Yeah, I might. So you kind of see it. There it goes. Hopefully it don't stop because I pressed the button, but it's very jumpy here on the video, but normally it's coming out in a constant phase, and if you can get them to drop on a mandrel like that straight out of the conveyor, it's a good way to automate some of these high-speed applications. So I wish I could show the videos, but I guess we'll just go by them. A few of the other challenges that we see, with a lot of different part sizes, et cetera, it's not just the part that may change, it's also the racks and the dunnage that may change part to part. So just putting a fixed conveyor back there with the same roller design may not work. But what we found, a lot of customers we see, they'll have somebody manually just putting the parts in the boxes, and then they also get on the forklift and move the dunnage out of the way and bring in empty dunnage. So a very simple conveyor system is kind of the low-hanging fruit to that. So at least that operator, you're not shutting the press off to change dunnage out. And then also you can have multiple bays if you have a robot there to be loading the different racks. That way when you fill one rack up, the line doesn't stop to start filling the next rack up. I guess the how to automate. So that's what we're kind of, I've seen the phrase low-hanging fruit in a few of these presentations. You know, you want to try to find the easy items to start with. Some of the easy stuff are the conveyors, you know, keeping the pallets or the dunnage or the racks moving. You know, you have to review all the parts to be ran on that press that need to be automated. Typically, you'll lay all the CAD geometry over each other, see if you can get an end-of-arm tool, you know, that can commonly grasp all the parts. You can do end-of-arm tool changers as well with that. Cycle time charts or simulations to confirm cycle times. Robotic tooling quick changes. And then, you know, when possible, the automation needs to go on a common base. That way you can completely run it off on your machine builder's shop floor before sending it to your place, just to reduce the amount of downtime that you may have. And then that also allows you to pull the equipment away from your press if for some reason you need to run a different model that the automation can't handle. So like I say, some of the low-hanging fruit was dunnage on skids. And then, you know, when dealing with boxes, you know, we've seen a lot of applications where there's people manually unfolding these boxes behind the press lines. You know, they have the box erectors and the box tapers. That's kind of the low-hanging fruit that we see compared to trying to automate your whole press system with 20 different parts. If we can do the easy stuff first, you know, that's typically the best way to go about it. And then when stacking boxes, you know, you can do the robotic palletizing. If you've been to an Automate show lately, they've got them about every robot booth. And we've done several projects like that with different robot brands to kind of make that happen. The program's pretty simple anymore. So, we'll see. Yeah, once again, you know, simulation. So, you know, when you're dealing with the high speeds, you really need to be considering doing simulations, you know, before you start building things. You know, if it's slower cycle times, you can get by with an Excel chart. But once you get into the high speeds, you know, it's just silly to start building something to that level without having some type of a simulation put together. And it's going to be hard to explain with it not operating, but basically you have a shuttle, and, you know, it's grabbing a scrap, a parent, and a child, and then it comes back out and drops it into the appropriate spot. And the next video should be of it kind of in operation now. So this is a picture of that actual system from the simulation to what actually got built. So, you know, the shuttle parts released from the bottom of the die. You know, we use electromagnetics where possible. And then the permanent magnets hold the scrap to release it from the upper die to evacuate it. The simulation might work a little better. So this is another example of kind of like motor laminations being stacked up. So as it's falling out of the press onto the mandrel out here, it drops onto another shuttle to bring it out to be grabbed. That way the press can keep running, and then you have the fingers to basically hold those parts up. So this is a lot of the motor laminations. It's pretty popular, but, you know, it can be applied to a lot of different applications. Basically, whatever we have to do, you know, obviously to keep the press from having to shut off when you're changing parts out. And when you're running those high strokes per minute, building that whip up to get parts in and out is pretty critical. Trying to keep up with a press running at 200, 300 strokes per minute with a robot or a pick and place is typically just not going to be feasible. So just some servo part retrieval systems, you know, some more automation going in, grabbing parts out of the press. You know, this is some pretty standard automation that you'll see in a lot of high volume press shops. Basically, it's designed and built per the application, a lot of servo motion, programming. It's a very process-dependent type design. And some more videos, still jumpy, but you kind of see what's going on. Basically just have a servo part retrieval that goes in after every stroke and pulls the parts, finished parts out. So, like I say, it's very application dependent. What we like to do is to go in with the customer, look at their project that they may be considering, and try to come up with a team solution is really the best way to go about it. And just more automatic press transfer type equipment. A lot of servos. It doesn't always have to be a robot system for automating these projects. A lot of servo pick and places, dial tables. It's a wide variety of solutions for the custom applications. And this is kind of the opposite. This is automatically loading. It's got a transfer system, and that enters the part through the line. A lot of different examples of different press automation. You kind of see it's on a dial table as well. When it's running well, it looks a lot faster. But it'd be. I don't think the engineers would be too happy if it actually moved like that. But anyhow, then the other thing that maybe gets lost in the shuffle of some of the automation conversations that happen. Downtime is downtime. So whether it's switching a coil out, the dual mandrel coils, hydraulically expanding mandrels, anything to keep the coil changes down to a minimum. When your straighteners, flatteners, levelers, when you need maintenance on the rolls, having a cassette that can actually pull out rather than trying to do the maintenance inside the machine. Any way to keep that time to a minimum, kind of goes more in the hand of that low-hanging fruit. It might not be traditional automation, but it keeps your uptime higher. Also, like we mentioned, coil cars, anything on that front end is kind of the easy stuff to keep that downtime lower. Yeah, a nice picture of our building. It's got an expansion going on currently, and that's kind of who we are. And I think that's the last slide. I do apologize. I wish some of the videos would have worked better. It would have been a little more talking points there. But I guess I'll leave it up for any questions at that point. It's all right. It happens.
James, so when you think about traditional manufacturing, maybe folks who haven't done any automation or maybe new to automation, to robots or gantry automation, what's let's say, the minimum amount of infrastructure and people resources that you need to be able to sort of successfully keep that equipment running over time after installation?
Yeah. Well, that all depends on what you're doing, right? The easy stuff, typically a maintenance guy, can handle, a powered conveyor. It's not going to be any more complicated than what they currently have. When you start getting into the robotics and servos, even if you don't have a huge maintenance staff that aren't used to that, there is going to be a learning curve. There's no doubt about it. But kind of going off some of the earlier slides that some of the other folks here were presenting, we typically put E1s in every cabinet at this point. That way, if the customer does have a problem, as long as they can get us dialed in or connected into that machine, typically we can support them by phone rather than having to be on site to fix it. Now, our service team is available, but in general, if you have a robot in there, you typically want somebody to be able to clear the simple faults. So I'd typically like to see at least one controls engineer overall, and a maintenance guy on each shift that can at least, jog and reset the robots, which, they're intuitive enough that it doesn't take a lot of training to get there anymore. We've installed a robot system in Minnesota just recently, and, that customer did have a robot, but, one robot, but their operators are now jogging that robot anytime they need to clear a fault, and it took about 2 weeks to get them to that point. Now, obviously, if it's a more significant issue, then that's when the E1 or the online support comes in.
You doing much with cobots in your
Oh, we have
customers?
typically not. A lot of the applications we deal with are the projects where, it requires a lot more engineering, a lot higher cycle time. Typically the cobots, a lot of our customers are able to deploy them themselves, or, if it's that simple of a project, usually the budget is relatively low, so we may recommend them to somebody that, doesn't have all the engineers on staff that can handle smaller projects like that.
Gotcha. Thanks.
Do you guys ever see customers looking for you guys to do managed services to actually be monitored? Since you mentioned you have a E1 router in the machine, do they look to you guys for offering monitoring services or anything like that?
Yeah, we've been seeing that request in the RFQs more and more. So historically, we have not done a lot of that. However, with a few of our larger customers, we have been adding. Typically, they've told us what type of monitoring system to use and what type of equipment to use based on their specs. But that has been a large consideration that I've personally been thinking about, is whether to just start adding an option onto the quotes for some of these data monitoring systems, just to give them an idea of what's possible and what's out there. I haven't done it to date to add that option, but it is something that we're seriously looking at doing. Yeah. So.
All right, thank you so much, James.
Thank you.
So that's a wrap for today. Please join us upstairs for happy hour. The bar is open. We've got